Okay. How many trolls can I attract today? This is hilarious. Okay. So, welcome everybody. Welcome. I'm just getting a kick out of all those people that likes to troll and waste their time. Apparently, I am that important that they want to come into my life. I'm sorry. I should stop talking. Hello. Hello. Sorry. My name is Lynette. Hello. We're doing it. What are we doing? We are looking at this abacus. This is the abacus. Hello. Welcome, everybody. We're going to do 7,567. We have 7,952. How does that work? Oh, sorry. Hold on. There we go. So how does that work? Well, if we look, all the beads has a number. All the columns has a number. And with the numbers, what we're doing is we're visualizing our numbers. So this is 7. We have 5, 6, 7. All the top bead is a value of 5. 5, 5, 5. Notice that this is not counted. This is not touching the reckoning bar, so it's not counted. Hey, nice tree! Welcome back. I was just thinking about all the trolls that come by. Anyways, but you're not a troll. I'm just thinking out loud. Hello, welcome. Hello. You're not a troll. Anyways. So we have 7, 5, 6, 7. We have 9, 5, 6, 7, 8, 9, and then we have 5. Notice that the bottom beads is a value of 1. 1, 2, 3, 4. And then it's touching this horizontal bar. This is what's being counted. Because this is being counted, this is counted as 5. So the top bead is a value of 5, and the bottom bead is a value of 2. So we have 1, 2, we have 5, 5, 6, 7, 8, 9, and then 5, 6, 7. Hello, everybody. Hello. Thank you, everybody, for joining. Hello. How are we doing today? Woo! I don't know what's going on. Okay, so we're going to continue on. We're going to color our abacus. We're going to color in 9. We have 9, 5, 6, 7, 8, 9. We have 5 and then 2. 1, 2. Hello, everybody. Hello. Thank you so much for joining. We are learning to read the abacus, and this abacus shows 7,952. And so the next number we're going to do is 4,178. Hello, everybody. Hello. We are looking at this abacus. Thank you so much for joining. We're going to do 4,000. We have 4,178. And we do our coloring in. We're going to color in. We do 1, 2, 3, 4. We have 1. We got to do one bead, just that's what that means. 1, and then we have 7, 5, 6, 7. We have 8, 5, 6, 7, 8. That's what it is. 1, 2, 3, 4. All of these beads are touching the reckoning bar. That's what this is. That's the touching the reckoning bar. So we do 1, 2, 3, 4. That's touching the reckoning bar. These beads are not touching the reckoning bar, so that means they're not being counted. This one is, so this is 1, this is 5, 6, 7, this is 7, 5, 6, 7. These 3 beads are touching the reckoning bar, and then this one, 4 beads are touching the reckoning bar. But when we're looking, we count it. We count the top bead is 5. The top bead is 5. We have 5, 6, 7, 8. 5, 6, 7. All right, we're done with that number. Next number, we have 6,338. Welcome, everybody. Welcome. Thank you so much for joining. My name is Lynette, and we are learning to read the abacus. We are going to read the abacus because it's just visualizing our numbers. So we have 6, 5, 6. The top bead is 5. The bottom bead is 1. We do 6. Right? That's what 6 is. And then we got to do 3. 1, 2, 3. Thank you so much for liking the live. 1, 2, 3, and then we do 8. We got to do 8. 1, 2, 3, 1, 2, 3, 8. 1, 2, 3. No, that's not right. We got to add in the 5. The 5 is a value. The top bead is a value of 5. Because we add the 5, now we have 8. If I take away the 5, it's not counted from the reckoning bar. Then this is 3. 1, 2, 3. But now we add the 5. This is 8. 5, 6, 7, 8. Thank you so much for liking the live. Thank you, everybody. Thank you so much. So I'm just coloring in my abacus, and then we're going to go to our next number. Our next number is 4,918. So clear my abacus. I have 4,000. Hello, Kimber. Welcome, welcome. We're learning how to read the abacus again, and we're just looking at our numbers. So we have 9, 4, and then we have 5, 6, 7, 8, 9. So 1, 2, 3, 4. We have 1, 2, 3, 4. Notice if I add this, it would be now 9. This is 9. How do I know? Because the top bead is touching this reckoning bar, so now we count it as 5. So it's 5, 6, 7, 8, 9. We have 1, so we're going to do 1. And then we have 8. 5, 6, 7, 8. Thank you, everybody, for joining. Thank you, everybody, for joining. My name is Lynette, and we're learning to read the abacus. Hello, hello. For those of you that are just coming in for the first time, please keep your mind open.
Open your mind to me, please. Open your mind.
Thank you, Nice Tree, for the rose. Hello, Trent. Hello. Good evening, good morning, good afternoon. I hope you are well. We are learning how to read the abacus. We're going to visualize our numbers. If you're ever wondering, what does it mean to visualize our numbers? Hello, Allie. So if I have these numbers and I have like 4 pens, the 4 pens is not visualizing numbers. What we're going to do is we're going to visualize numbers. So when we look at it, we have 8. 8 looks like this. 5, 6, 7, 8. So when we look, we have 5, 6, 7, 8. The top bead is always a value of 5. And then we have 3, 1, 2, 3. We have 9. We're going to do 9. 5, 6, 7, 8, 9. The top bead is a value of 9. Notice when the top bead is touching this reckoning bar, it is being counted. So our next number is 2. We do 1, 2, and then we have 0. How am I doing? I'm doing really well. I'm doing really well. In the beginning, during the day, I had a little bit of a headache, but I think it's now subsided, and I think I am full on learning how to teach abacus to the matrix. I hope you guys are in for a ride. I don't know how long we're going to be on, though. Why do I start? That's a great question, Lyndall. That is a very great question. Thank you so much. Thank you so much for commenting. Why? Because I like to know that I'm not the only one in the room. Right, Trent? So, the reason why, Lena, you don't need to swear. If you don't want to, if you're going to continue to swear, then you can leave. That's not nice to be swearing in my room because you don't know how old the people are here. So please, do not swear in my room. Okay, where are we? Lendo. Okay, so when we're looking, we have ones, tens, hundreds, thousands, 10,000s. Yes, please be careful because I do have children in this room. I'm not saying you are, but I do want to recognize that we have children in the room, and please do not swear. Thank you so much. Okay, so Lendo, when we're looking, we have our ones. When we have our ones, we're counting 1, 2, 3, 4. All the bottom beads is a value of 1. So notice that if this is my ones, just like how we write, we have our decimals. Our decimal sits between our ones and our tenths. Because it sits between our ones and our tenths, this is our decimal. So then we have 1. They've heard of course words before. Yeah, they have, but I don't want it to be in my room. So you can leave because I don't want to be in my room. So if you look, this is the tenths and then this is the hundreds. Thank you, Dubious. So when we're looking, does that make sense? Does that make sense, Lendl? Right? So when we're looking, we have our tenths. We have our 4.1, 2, 3, right? 1, 2, 3, and then 7. So we could do 7 and we could do 5. 75. So when we're looking, we have this 4.75. Make sense, Lendl? Oh, good. Thank you so much for commenting. So when we look at it, we can do our thousands. We could do 55,555.55. So what does that mean? Well, when we're looking, we can do 55,555.55. Right? And then if we wanted to, we can actually go to here. I just need some paper. Hold, please. Okay. So Now, the other thing is, if I wanted to, if you notice, I actually have these labels. These labels right here are these ones label. So you'll notice I have two groupings. There's a grouping here, there's a grouping here. If I choose this one over here, like a Pokemon,
I choose you.
then I can actually make this as my ones place. So I would move everything over and it would look like that, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. There we go. So when we're looking, but notice I don't have any more room for hundreds. Because I have no more room for hundreds, I don't want to use this one because I don't have enough room for hundreds. I could do 10, 20, 30, 40, 50, 60, 70, 80, 90, and then there's no hundreds. However, because I can do this, I can actually do 9.00001. 90.00001. That's what that would look like. Does that make sense? So what we're doing is every column is a place value. Oh, thank you so much. Hello, Kimber. I'm sorry. There's a whole lot of comments and I'm just kind of, thank you everybody for understanding to be careful with your words. Thank you, Nice Tree, so much for the heart, finger heart, and the roses. Thank you so much. Okay, so thank you for the follow, Lendl. So when we're looking, right, that's what we could do. Now, if I wanted to, I could choose this one. I usually do this one over here.
Okay, Charizard, I choose you.
And I move everything over and this will be my ones. Then it goes back to what it was before. My ones, my tens, hundreds, thousands, and 10,000s. And then I have my decimals. Now, if I really wanted to, I can use a bigger abacus because size matters. Okay, why? Because this is a 13-column abacus. This is a 7-column abacus. The 13-column abacus just means that I can have more digits. And I can also figure out, like, depending on which dot I want to choose, now it can be any dot I want. So if I choose this one over here, this dot over here, then I have my ones, tens, thousands, hundreds, ones, tens, hundreds, thousands, right? Then I can do millions and I can do billions over here. However, if I choose this dot over here, right? So it doesn't matter. The dot's kind of movable. You just need to figure out where your home is. You just need to figure out where your ones place is. So I could do this one. This would be my ones, thousands, millions, billions, and then trillions. And there you go. Right? And it obviously can go the other way too. If I choose ones over here, then it'd be all of this to be my decimal. And I can have a really, really small decimal. Now, the reason why the colors don't mean anything. When you look, the colors mean nothing. It just means the placement of the value. There's just the placement of it's just the positioning of the beads. So when we're looking, we can count 1, 2, 3, 4, 1, 2, 3, 4. Right? And then what are we going to do? We could do 5, like that. 6, that's what 6 looks like. 7, 8, 9. 7, 8, 9. So then, obviously, with 10, we could do 10. There we go. Nice Tree. How much is the smaller one? The smaller one is $10 and the bigger one is $13. That one right there. I wish. Oh, right. This is so cool. This is making sense. Right. Hello, Katie on the daily. Yes, right, Dubious. It's so crazy. It's so crazy that if you actually saw your numbers, you would be able to do math easier. And I'm going to tell you. But the first thing we're going to do is we're going to continue on learning how to read the abacus. So I'm going to continue on with my maze. This is a 4-digit maze, and I'm going to do 8,125. So now it all makes sense, right? So we have 8,125. Yes, right? This is a calculator. It's kind of like a calculator, but you actually do the calculations in your head, which is really kind of interesting. It actually just shows you. It's, funny. It's really just a counting tool. But the fact you could see the numbers, it's crazy that you can do a lot more if you can actually see and visualize the numbers, which is crazy. Which is really crazy. Like, I started going down this path, like understanding like how to read it and stuff. And I'm going to show you how to add and subtract, multiply and divide. However, what we're going to do is we're going to understand that all this does is just tells you what the number is. So my next number is 3,074. It's crazy. It's so crazy. So thank you everybody for commenting. Thank you so much for commenting. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
I am here to teach the Matrix how to use the abacus. Welcome, everybody. Welcome.
Welcome to the real world.
All right, so we have our 7,300, 1, 2, 3, 1, 2, 3, and then 5. Notice the top bead will always be 5 no matter what. So when I color it in, this is 5, and then we have 3. All the bottom beads underneath the reckoning bar is a value of 1. So we have 1, 2, 3, 1, 2, 3, and then 5, 6, 7. Even though there's 3 beads here, you have to pay attention to the top bead. The top bead is what gives it a value of 5. So we have 5, 6, and 7. And then our next number is 6,875. So we do this number right here, 6,875. That's it. So when I color it in, I do 6, 5, 6. We do 8, 5, 6, 7, 8. We have 7, 5, 6, 7. And then we do 5. Welcome, everybody. Welcome. My name is Lynette, and we are learning how to read numbers on the abacus. And it's very late for people. I can't believe you guys are learning math in the middle of the night. Welcome, everybody. Welcome. So our next number is a 3-digit. It's a 3-digit. If it's 3 digits, we only need to use 3 digits on our abacus. So when we're looking, we do 5,870. No, 587. That's what it is. 587. So we're going to do only 3 digits. 5 and then 8. 5, 6, 7, 8. 7, 5, 6, 7. And that's it. Hello, Nico. Welcome. Welcome. It's been a little bit. Okay, so for those of you that are interested, this is a 7-column abacus. It is a colorful abacus, and it's just, the kids like it. The kids like it, but you know what? I like it too. We have 7,016. So we're going to do 7,000 on the abacus, and we do 1 and then 6. That's what we're doing. So we have 5, 6, 7. We have 0. We have 1. And we have 6. 5, 6. There we go. So then we have 7,016. Hello. Will it make me faster at math? It will if you practice. We can only do, there's only 4 things you can do with it. Adding, subtracting, multiplication, and division. So, yes, it will. Thank you, Nice Tree. I do appreciate that. I do have a lot of people that have been learning the abacus, and they do feel like that they're starting to do their math a lot quicker. So, but it's only, it's only the 4 things that we do in the abacus. So the only thing we can do is adding, adding, subtracting, multiplication, and we can do division. So, thank you, Nice Tree. Thank you, Purge, 1984. That was a good year. That was a really good year. So we have 2,781. So we have 2,000. I'm going to color in 2. We have 7, 5, 6, 7. We have 8, 80, 5, 6, 7, 8. And then we have 1. Welcome, everybody. Welcome. Thank you so much, Purge, for the follow. Thank you for the follow, Hyper QT. That's funny. All right. So, are we ready? It is now your turn to let me know what these numbers are. Is this a test? Yeah. Okay. Is it a test? It's not really a test. It's kind of just to keep you guys entertained and active. And you know what? Stop from doom scrolling, and we're going to actually learn something. This is cool. I've never been so entranced by math. I know, right? Wait till we start going into adding, subtracting, and multiplication, division. It's crazy. And thank you, everybody, to keep your mind open, because why?
Oh, I love it. Great stuff.
And I've got jokes. So we have our next number. Please let me know what number you think this is. So we have our thousands, our hundreds, our tens, and our ones. What number do you think this is? Come on.
Come on, do it. Do it.
Ah, Nice Tree. Thank you. 3. It is not 3. 5, 6, 7. Thank you, Dubious. 9. 5, 6, 7, 8, 9. 1, 2, and 1. I'm me, a math teacher in the math grade, and I am Hannah. I know. No, this is a secret. This is a secret. It is the greatest secret. I am here to tell you. I am here to introduce Abacus to the Matrix. Thank you everybody for joining. Thank you everybody for joining. So it's just crazy on how you can see these numbers, and once you are able to visualize these numbers, then it will be easy to do adding, subtracting, multiplication, and division. Thank you everybody for joining. My name is Lynette, and I have a bunch of Abacus workbooks. They're all available. No, they're all available here. I am still bringing up my Abacus TikTok shop, but I do have it here if you're looking for Abacus worksheets. Workbooks. Excuse me, workbooks. But I don't understand how it works. I just joined. Oh, hey, welcome. It is 1, 2, 3, 8, 5, 6, 7, 8, and then 4. 1, 2, 3, 4. Ah, I just might buy them. Oh. Thank you, Dubious. I do appreciate it. I am here to help, and I am here to entertain, because I think my books are the greatest thing next to sliced bread. Why? Because this is also a book. It is a maze on how to read the Abacus. We did 1,384. And I was in the process of trying to teach kids, but then I noticed that adults like it too. Just like when we color. So I added some color by numbers with math. And it's crazy. So we do, because it's kind of like Sudoku. I don't know if you like Sudoku, but it's kind of like Sudoku. It's kind of like crossword puzzles, jigsaw puzzles, word searches, and chess. Because it's still like a little, puzzle trying to understand. Like there's enough information, but you still need to think. So we have our thousands, our hundreds, our tens, and our ones. It was, but I don't know the multiplier. I could see that. Oh, yeah, right? So when we're looking, thank you, Purge. We're going to start going into it. Oh, I play Carol literally every night. Now it makes sense. Because it's a puzzle. It's really fascinating. Oh, I love it. I love it. You know, the people that do started on the Abacus and they're adults, they do notice that they're starting to think a little bit faster, because what we do is we jog the brain to do some arithmetic, which we don't do very often when we're old, right? Thank you. Yes, Mrs. Bright Lights. Woo! 7,582. Well done. Nice tree. Well done, Nickel. Okay, 7,582. Yes, well done, well done. So I'm going to color it in because it's my maze, and I am over here. Now, what is our next number? We have our thousands, hundreds, tens, and our ones. We have our thousands, hundreds, tens, and ones. Hello, thank you, nice tree. 3, 2, 9, 5. Well done, nice tree. Well done. Thank you, Hannah. Yes, thank you, Nickel. Thank you, Dubious. Woo! You guys are on a roll. Here we go. Here we go. Here we go. Here we go. Okay. Thank you, everybody, for commenting and letting me know what number you think this is. I feel like I'm a flight attendant, and over here is an exit, and over here is your seatbelt, and over here is your tens and your ones. So when we look, when the beads are touching the horizontal bar, right? This is the reckoning bar. When they're touching, that's what's being counted. So when it's being counted, thank you. It is 1,700,567. The top bead is 5. The bottom beads are 1. And then we have it again. We have our 5 plus 3 is 8. And then 4. 1, 2, 3, 4. Thank you, guys. Thank you, everybody. Thank you, Dragon. Thank you, Hannah. Thank you, Dubious. Thank you, Nickel. Well done. So we have 1,784. Well done. So our next number is... Okay. We have our thousands. We have our hundreds. We have our tens. And we have our ones. What number? We have our thousands, our hundreds, our tens, and our ones. This is amazing. My nerdy brain is... Oh, good. Oh, good. Thank you for the amazing lesson. Oh, you're welcome, Nice Tree. Thank you so much for coming by. I hope that you have a good night. And I'll see you in my next live. Thank you, Hannah, for the comment. This is fantastic. Oh, I love these comments. This is what makes it great. This is what makes it great. This is fun. Oh, I'm so happy. I'm going to bed. Okay, go to bed. Okay, Dubious, thank you so much for joining. And I hope I see you in my next live. I will try to be here earlier because it's late for you guys. Bye, everybody. You're the only person ever described how to use and read without being confusing. Thank you, Thantan. See you later, Dubious. Oh, thank you so much, Nickel. Thank you so much. I appreciate that. And I got jokes. I got jokes. That's what it is. The abacus is more than meets the eye, which is crazy. It's so crazy. It's such a simple tool. I'm telling you, it's such a simple tool. But guess what? It's amazing. Okay, so we got this number, and then we're over here. What number do we have? We have our thousands, we have our hundreds, we have our tens, and our ones. Thank you guys so much for joining. Thank you so much for joining. Let me know what number you think this is. So every column that is touching the reckoning bar is counted. It looks like there's only 4 columns being counted. We have this one, which is our thousands, our hundreds, our tens, and ones. Welcome. Thank you, Hannah. Thank you, Purge. Ooh, almost. Almost, Purge. Thank you, Then. Yes, 7,567, 7,567. This is 700, and this is 4. 1, 2, 3, 4, and then we have a 5. Well done. Thank you so much. Thank you. Thank you. So we have 7,745. Well done. So we have 7,000. Oh, there it is. 7,745. Whew. What is our next number? We have this, and that. There we go. So we have our thousands, hundreds, tens, and ones. What number do we think that is? Thank you, Austin. Well done. 2,939. Well done, Austin. Thank you, Hannah. Almost, Purge. When now we have the 4 up here. So we have the 5. So we do 5, 6, 7, 8, 9. We have 8. We have 8. It is not touching the horizontal bar. The 5 is not touching the horizontal bar. We have 1, 2, 3. And then we got the 9. 5, 6, 7, 8, 9. And then we have 2. 1, 2. Are you all right, Purge? Let me see if I can make that better. Does that make sense? I know I'm moving it a lot, too. Thank you. Yes, thank you. 2,939. Because it's 5, 6, 7, 8, 9. Right? Could be a typo. All right, what's next? We have our thousands. We have our thousands. We have our hundreds. This is our tens and ones. We have our thousands, hundreds, tens, and ones. I'm tired. Yeah, I understand. I understand. All right. But it makes sense, right? Okay. I'm okay. Thank you, Purge. 4,747. Yes, well done. Colloquial rubbish. Remember to stay hydrated while teaching about this abacus. Yes. Thank you so much. Thank you so much. I appreciate that. Colloquial rubbish. Thank you so much. Thank you, Austin. So we have 4,747. Well done. And then our next number is, we have thousands, hundreds, ones, and then, tens and ones. Thank you guys for joining. Thank you for liking the live. And what is the next number? 9,918. Well done. Thank you, Lucky Red, for the follow. Ooh, Austin, almost. Oh, really? You see the abacus? W, when you see the abacus, even if it's a 10-beat abacus, it will be good. Because if it's a 10-beat abacus, I can tell you how to modify it. Because we can do some modifications.
You need modifications. Modify.
Oh yeah. Yeah, 10-beat. Yeah, there is a 10-beat. I don't have an example of it, but there is a 10-beat one, and the 10-beat goes across. A 10-beat goes across. And if it goes across, we can modify it. And I can show you how to modify it. So if I have a 10-beat, it'll be like this: 2, 4, 6, 8, 10. Yeah. So W, when you get it, is the 10-beat the longest? Yeah, 10-beat is no, you know what? I take that back. There's another one in Target that's 11 beads, and I'm not understanding why. I think it's just for cosmetics. But in Target they have one that's 11 beads. But so what I did was somebody had a 10 bead one, and when you look, you can actually modify it. You would tape the 5 up here. You would tape 5 like that, and then you would flip it. So you would do that. So it would look like the abacus, right? And then we could do this. This would be 5, and then that would be 5. And then you would have a string like that. You would have a string that would touch it. So it'd be string, and then you'd be 6, and then that would be 6. There'd be 7, this would be 7. This 8, and the 8. 9, and then 9. And then you would ignore this bottom one. But when you get it, if you get it, W, let me know and we could talk about it. I feel like I need to get an abacus now. Hannah. Yeah, wait till we get to adding and subtracting. You're going to really like it. It's just amazing. It's amazing on how easy it is. So it is, thank you, Purge. Thank you. So our next number is, those are so cool. Thank you so much. So we have our thousands, hundreds, tens, and ones. We have our hundreds, thousands, tens, and ones. What number? Thank you, Austin. Thank you, Zozo. I'll pick up the next one. I find it. Okay, yeah. Yeah, when you do, let me know. Come and see me, and then we will talk about how to modify it, because it is possible to modify it. Thank you, Austin. Thank you so much, Hannah. Thank you, Purge. It is 6,671. Well done. Well done. 6, 5, 6, 5, 6, 5, 6, 7, and then 1. That's what that is. So that's what the number is. 6,671. And then we have our, that's it. We're done. And then we can start going into some adding and subtracting. I'll show you how easy it is. It's crazy. So we have our thousands, our tens, our hundreds, thousands, hundreds, tens, and ones. What number do we think this is? Thank you. 2,000, 1, 2, 7, 5, 6, 7. We have 3, 1, 2, 3, and then 9. 5, 6, 7, 8, 9. Thank you, Austin. Thank you, Purge. Well done. Okay, so, I think I'm caught up with all. I'm so hyped for the addition and subtraction. I literally double majored at 2 kinds of math. Really? Yeah. Okay. Let's talk about this. It's interesting. So thank you everybody for joining. My name is Lynette. I teach Abacus. I've been teaching Abacus for about 20 years. I have books available in my TikTok shop. I also have books available here. My collection is actually from here, but I do plan to stock my TikTok shop for these books as well. So the first thing we're going to do is we're going to understand how to move the beads. Notice that the abacus themselves, there's an edge to it, right? Because there's an edge, you just want to use your fingers to gently move the beads. These are very easy to move, right? We don't want to be aggressive, because if we're aggressive, then the answers will become wrong. Why? Because the beads are very easy to move. Because the beads are very easy to move, you want to use your left hand to hold the abacus. But if I'm using my left hand to hold the abacus, it doesn't matter if you're left-handed. The reason why is because it will stabilize the beads. But if I said we did this 5 5 5 5 5 5, and you did this and you flicked, don't flick. The reason why you don't want to flick is because your answer becomes wrong.
And flick. Oh, flick too hard, damn it!
So don't flick. The reason why is because these beads are very easy to move. Because they're easy to move, and it doesn't matter how big, burly your hands are, you should still be able to use the beads. The reason why is because you just want to use the edges of the beads to move it. So don't flick. And then we talked about the placement value, right? There's the ones place over here, or we could do here. So if you notice, we can have our ones. If you see that there's a label, this is our label, we could say this is our ones. So if I use that as my Pokemon.
Okay, Charizard, I choose you!
Hello, Chaotic! Welcome back! How is it going? It's been a little bit, hasn't it? So we have our tens, our ones, our tens, our hundreds, our thousands, our 10,000s. Notice that these dots right here, they're our grouping. So I know that this is going to be my thousands. I don't have to count it out again. It's like a little label just so we know where we're going, right? And then if I choose this one to be my ones,
Pokemon, I choose you!
then I would be moving this over, and then this would be considered the ones. So be my ones, my tens, but notice I have no more room for thousands. Okay, so that is a little bit about the anatomy of the abacus. Let's go into understanding how to move the beads. Moving the beads is what? Moving the beads is making sure we understand how the beads just move, exactly what that means, right? The reason why is because sometimes it gets a little finicky. Here is my book. This is meant for kids that are 3, 4, and 5. Those are beginning to learn how to read the numbers and understand what numbers are in the world, in the world. So the idea here was there was going to be some tracing. So there's some tracing, and then these are all abacus-driven activities. And I have it where they have other activities like this maze. This maze was just to see what the number is, and then to find what the abacus number is. And again, here's a maze. This one is a pixel art, and then this one is another counting number. This one is lesson 2. Lesson 2 is from 5 to 9. Again, what we're doing is we're just understanding when you add the 5 and you add the 1, now we have 6. If I do 2 plus 5, it's 7. If I do 3 plus 5, it's 8. And then 4 plus 5 is 9. So again, I have more activities about how to read the abacus and what the numbers mean, and then there's tracing and making sure that they understand, eye-hand coordination, just to make sure, and then they count forward. After they count forward, then the next lesson is how to count backwards. After counting backwards, we figure out what comes in between, right? And then after they come in between, then they figure out what comes, what's surrounding. So if I give you the number in the middle, what's surrounding? And then after that is comparison. We understand what the bigger than and less than, but we need to get into understanding how to move the beads. Now, do you teach? I do teach. I do have private tutoring. I also have online classes. The online class is self-based, and they're all video-based if you're interested in. I do also provide private tutoring as well, and if you want to know more about my services, you can DM me and we can talk about it. We can do a meet and greet. Thank you just for the rose. Thank you so much. So I do, and then I also have workbooks and worksheets and a lot of video. I have a lot of video and a lot of content. What is this specific grade for? This one specifically was for preschoolers, for children who are 3, 4, and 5 are learning just what their numbers are. That's what this one is. But we're going to get into more. If you're looking for something a little bit older, then I would suggest going into this Abacus Mazes, which is a 2-digit, depending on how old they are. So if they're 6, 7, 8, 9, right? They know they're 2 digits, or they could do 3 digits. And what this is understanding how the beads, what the beads are, the recognition of the beads. So this is the hundreds, the tens, and the ones. This one is the tens and the ones. So for when we're looking, and then what is it? It's a maze. And what we do is we're learning to read the numbers. You figure out what the number is on the abacus, and then you find the path. Then the next one is, I give you the path, but you have to color in the number. And then if you're ever curious, the answers are in the back. I do have it for both, and I do have it in my TikTok shop. It is available in my TikTok shop. It also comes, there's a package, a bundle that comes with the abacus as well. So, and I also, in the beginning, just so you know, I do provide instructions on how to read the abacus as well. So here we talk about, what the ones is, and then we start talking about the place values of tens and ones, just in case we forgot, what the tens are, and I try to mimic how it looks on the abacus. So that's what this is. And then we start talking about the hundreds. Why? Because this is 3 digits. So I just do a little review on what the 3 digits look like. So this is 5, this is 4, this is 7. And again, it's the mazes. Cool. So we're back to understanding how to move the beats. So notice in Abacus World, what we do is we focus on the second number. When we're looking at it, we want to focus our second number. We're not focusing on the result. The result is mainstream. We don't focus on the result. The reason why is because the second number is going to tell us whether or not it dictates whether or not we use a formula. So this one specifically is 7. So I have on my abacus, I have 7, 5, 6, 7. Notice my question will always be, do I have enough? Can I add the 7? Yes, I can. I can add the 7. I can add the 1. I just need to add this 1, and my final answer becomes 8. 5, 6, 7, 8. So what I do, I just add the 1. It doesn't matter if I add this 1 or this 1 or this 1 or this 1. I just need to add the 1 bead. That's all I'm doing. So again, when I do 2, my question is 6. I want to add 2. Can I add 2 beads? Can I do it? Yes, I can. So I can add the 2 beads. My final answer is 8 again. All right. So the next number is 3, right? So you could use dots like mainstream math. You could do that, or you could use tally marks, which is fine too. Tally marks kind of mimics the abacus, kind of, but. And then on the abacus, it's the 5 plus the 3. Notice I'm going to the horizontal bar, I'm adding the 3. My final answer is 8. However, now it becomes scalable. Why? Because if I wanted to do 50, 50 plus 30, 30, my final answer is 80. You could do the dots, but that's a whole lot of making dots. And then we can actually scale it again. If I want to do 500, 500 plus 300, 300, now I have 800. So you see that now it's easy to supertize. It is hard to supertize what this is. What does supertizing mean? Supertizing means that if I give you this number, you will know, and you don't need to count it. You will know that this is 9 because every column is 9. 9, 9, 9, 9, 9, 9, 9. Right? Even if I did this, 5, 5, 5, 5, 5, 5, 5, 5. Reason why is because the human eye can only see like 5 things at a time. Oh, thank you, Sophie. The human eye can only see 5 things at a time, but we also have our place values that we can also count. So when we do 5, we could do this. This is 4. How do I know this is 4? Because I could see it. It's easy. We don't need to count. 1, 2, 3, 4. It's easy. Right? So that's what 4 is. So on the abacus, I want to add the 5. I want to add the 4. So my final answer is 9. Thank you, everybody. Thank you so much for commenting. Thank you for being patient and learning how to use the abacus. For those of you that just joined, please keep your mind open.
Now, open your mind to me, please. Open your mind.
Thank you so much for joining. So now we know how to add. We go to the horizontal bar, 1, 2. And then when we want to subtract, we just go away. So notice that we're adding. If you know how to add, you will know how to subtract. So it's just the opposite. Whereas in mainstream math, there's different strategies to add and there's different strategies to subtract. Hence, they talk about doubles. Memorizing doubles is just adding only, whereas in subtraction, it'd just be 0. There is no such thing as double minus, which is interesting. Okay, so here we are. We're going to do 2. Again, we're going to add the 3. We go to the horizontal bar. We're going to subtract 2. 1, 2, and I just need to subtract the 2. My final answer is 1. And then what are we doing? We can do it again with the 4. The 4 is easy. We add the 9, we take away the 4. Notice I take away the 4 means I'm taking it away from the horizontal bar. What happens now is we do 5. 5 is, we add the 3, and then we're going to add the 5. All we got to do is add the 5. That's it. We minus the 5, take add the 5. Minus the 5, add the 5. And that's it. So then we could do it again with the 6. When we add the 6, what are we doing? We add the 6. So we have 2 on the abacus. I want to add 6. Adding the 6 means 5 and 1, and you bring it together. You take it apart, that's minus 6. You add it, that's adding the 6. Cool? And then it's again with the 9. 9 is easy because it's all together or it's minus. And that's it. All right. So, hey, Bluey. Natalie. Oh, hi, Natalie. I'm here again. Hi, I'm happy to see you too. I remember Bluey. I don't remember Natalie. I don't think I remember your name as Natalie. I don't think you ever told me, but I remember Bluey. How you been? It's been good? You all right? You're just in time to learn how to add the 5. We are now going into adding of the 5. Do you remember how to add the 5? So what's something like 9 plus 6? Ooh. Okay. Hold. Let me add it. Let me put it in my notes. Okay. So we have 5, 3, 9, minus 5, 8, 6. We could do this, but you're going to have to keep, Purge, you're going to have to keep the negative in your mind. Okay, so Hannah, you said 9 plus 6. All right, we're going to jump ahead. What does that mean? 9 plus 6. We need to know how to make a 10. We know how to do that. That's pretty easy, right? We know what? We know that 6 and 4 is equal to 10. Right? Hello, chaotic. So, what we're going to do is we're going to understand how to do 6 plus 6 add the 10. Why? Because we have a question. We need to know a couple of things. It's a concept. The concept is we're going to do how to make a 10. This is very critical concept in Abacus world. Why? Because we need to understand that 4 and 6 is equal to 10. There is a formula that we do. It's called adding the 6 is equal to plus the 10 minus the 4. Why are we doing this? Because we're going to substitute this information for the number 6. So the question is 9 plus 6. So you'll notice that if I put 9 on the abacus, I want to add the 6. But to add the 6, I don't have enough beads. Guess what I'm going to do? I'm going to use my money. So I have my money. Oh, where's my 5 cents? Oh, here it is. So I have 9 on the abacus, right? Guess what? I don't have enough to add the 6. But I can make a 10 out of it. If I make a 10, I need to give this to you, but I need to take away 4. So my final answer is 15. I could show you again on my abacus. I can add the 10 and then take away the 4. So my final answer is 15. Does that make sense, Hannah? So what did I just do is I modified and I made a 10. We could do it again with here. So let's do 9. 2, 4, 6, 8, 9, right? And then we do it again. We're going to add the 6. We can add the 6. 1, 2, 3, 4, 5, 6. This is fine. What happens in mainstream is you go up. But in Abacus, we go down. What does that mean? We make the 10 at the 6. So we know that 6 plus 4 is equal to 10. We know this. We got to get the 4 from somewhere. 1, 2, 3, 4, 5, 6. We need to get the 4 from somewhere. So here's my abacus. We need to get the 4 from somewhere. The 4 comes from the 9. 1, 2, 3, 4. We got to take it away from the 9. Then we can add it to our 6. This becomes 10. That is what we do in Abacus. We don't do it the other way. We don't make the 9 a 10 because the 9 is not what's making us add or subtract. It's the second number. The second number is what it does. So when we're looking, now we can do it. We can do it again. So we have, what are we going to do? We're going to do 8. So let's do 7. Let's do 7. Thank you, Chaotic, for sharing. So we do 7. So what is 7? 7 is 7 plus the 3 equals to 10. So what do? We can do it again. We have 9 on the abacus. I want to add the 7. To add the 7, I need to make the 10, but I have to take away the 3. So if I have my number 2, 4, 6, 8, 9, and then I have 7. 1, 2, 3, 4, 5, 6, 7. So instead of combining it all, oh, you can't see that. Instead of combining it all, right, and then reworking it, we are already organized. In this, we're already organized. We already know that we got to to make a 7, to make a 10 out of the 7, 1, 2, 3, 4, 5, 6, 7. To make 10 out of this, I need to add 3. But the 3 has to come from somewhere. It has to come from the 9. So I'm going to take it away from the 9, to make a 10. So I made a 10. So my final answer is 16. So what are we doing? We're balancing the equation. What we're doing is we're substituting this information, 7, with this information, plus the 10 minus the 3. That's what we're going to do. That's what it is. So we have 1, 2, 3, 4, 5, 6 is left on the abacus, or left on my number. That's what we're doing. So when we do it, we balance the equation, and what we do in the... Oh, have a good night, Purge. Thank you so much for joining. But yeah, with your negative number, you would have to keep the negative in your mind, if that made sense. Tired. Yeah. Have a good night. Thank you so much for joining. I'll see you in my next live. Hopefully it'll be earlier. Hopefully I will come on earlier. All right. Does that make sense, Hannah? So we could do it again. And it repeats. The reason why is because we want to make sure we understand how to make this, and then everything becomes easier. Everything becomes so much easier. And so let's continue on with the process, right? So I have 14 on the abacus, 1 and 4. I want to add the 7. I don't have enough beads to add the 7. Guess what? I have enough to take away the 10, take away the 3. So I take away the 3 and I plus the 10. So my final answer is 21. I probably need to practice, but I understand. Yeah, it's all about practicing. And it's the same thing with the 5. So that was the thing, right? What we did is we kind of jumped a little bit, which is fine. But I usually talk about how to make a 5 first and then how to make a 10, because making a 5 is a little bit easier to digest. So let's talk about how to make a 5. Thank you for the question. So the question is 4 plus 4. Now, when we're looking, we have 4 on the abacus. I'm going to have 4, right? Now, I want to add another 4, but I don't have enough beads. I don't want to add it here because that would be 44. What I need to do is I need to add it on the ones column. To add on the ones column, I'm going to utilize this 5. To utilize this 5, I need to take away the 1. So my final answer is 8. 5, 6, 7, 8. So I add the 5 and I take away the 1. So it's a little bit interesting because what we're doing is we're substituting this information for an equation. The formula is adding the 5, but you have to take away the 1 so we can be balanced. That's what we're doing. We're balancing the equation. Let's do it again. So here, if I have 3 on the abacus, 1, 2, 3, right? And I want to add the 4, but guess what? I have this package. This package has my 4 dots, my 4 cubes. I'm only going to use these 4 cubes. But because I'm restricted with this package, I need to take away this 1. But I don't want to break it. I don't want to break this. I can take it away from my loose one. So when I take it away from my loose one, right? That's what I do. I take away from the loose one and I add my package. I add that. And then my final answer is 7. That is what we're trying to do. It's because there's the beads inside here. You could see it, right? You could see the beads. It's all in here. So it's all the same. This is 5. And then this is 2. So the together is 7. We could do it again with the 2. So 2 on the abacus, right? 2 on the abacus. I have 4. But I'm stuck with this package. This package only has 5. So I'm going to count 1, 2, 3, 4. This 1 needs to be removed, but I can't remove it because it's taped or glued or whatever. But I can remove it from here. So I'm going to take it from here. So I add the 5, take away the 1. So my final answer is 6. 5, 6. And that's it. That's the concept. That's the concept of abacus. And if you know how to add 5 and you know how to add the 10, then you'll be able to add and subtract at scale. you will be able to add and subtract at scale. So here is a question. Here's my question. We have 1 on the abacus, 1, 3, 5, 7, right? And then we're going to ask, can we add 2? Yes, we can add 2. 1, 2. Can we add the 4? Can we add the 4? Yes, we know how to add the 4. Plus the 4 is equal to plus the 5 minus 1. So I plus the 5, take away the 1. And then I want to add the 3. Can I do it? Yep. 1, 2, 3. And then add the 1. So my final answer is 3,788. Bam! That's it. Easy? Thank you for the follow, Michael. Are we okay? So which one are we doing now? We are doing this one. Yeah, it's really quite interesting. I was trying to break it down too, and it was like fascinating to be able to make it more relatable to mainstream math, and that's why I put in these blocks. So then that's how we do it in Abacus World. But in Abacus World, we tell the kids, you got to memorize. However, I'm telling you why we're doing it and how we do it. So we can do it again with the 3. Notice that there's a set. So we did the 4, we have to do the 3. To do the 3, it's minus the 2. When we minus the 2, what are we doing? We do 4 on the abacus, and we have the 3. 1, 2, 3, 4. I've lost a penny. Yep, I've lost the penny. Okay, so much better remembering. I know, right? It's so crazy. So I add the 5 and I take away the 1. I had another penny. I can't find it. I had my penny. Yeah, it's crazy. So oh, here it is. If you can understand it, it goes deep. It goes really deep. And it's just crazy. So we add the 4. I want to add 3. To add the 3, I don't have enough, right? 1, 2, 3. I'm going to add my 5. To add the 5 is, what am I going to do? I need to take away the 2. So I'm going to take away the 2. My final answer is 7. 5, 6, 7. I can do it again on my abacus. Add the 5, take away the 2. Do you go from left to right? I usually do left to right. You could go right to left. Thank you for the follow, Michael. Does that make sense? And you know, it's interesting because in abacus, when we go left to right, it seems more natural. It just seems more natural. And it doesn't seem as you like going 2 steps forward and 1 step back if you go from right to left. So, I mean, we could do it. It doesn't matter for this one. It doesn't matter if you go right to left or left to right. It doesn't matter. So even if we did it, we did 1, 3, 5, 7. It doesn't matter because we add the 1. We can add the 1. Add the 3. Add the 3. Add the 4 plus the 5 minus the 1 and then plus the 2. You could, but to me it's a little bit backwards because I've been doing it. I've been teaching abacus for about 20 years now. So and when my boys went to public school, they didn't need help, and so so I have to do some research on how it's being done in mainstream math. Sorry. If you have one more, I'm sorry. Ha! You know, I don't know. It could be abaci, it could be abacuses, or it could be, I don't know. I think those are the 2. Yeah, I don't know. Somebody, I was asking about that too. I don't know. I think it can be both. It could be abacuses, or it could be abaci. Something like that. We need a word. I don't know. Right? Okay, good. Hannah, so that makes sense? Oh, yeah. I mean, it gets better. It gets better because when we start doing bigger numbers, it's crazy. It's crazy. So, these are great questions. Thank you, Hannah. Thank you so much. Okay. So we do 13 abaci. I think it is abaci. So 1, 3, 1, 8. Okay. So when we're looking, it would be making the 10 and adding the 2. Yes. So when we're looking, we do 1, 3. We add the 8. Adding the 8 is plus the 10 minus 2. So we're making our 10. We're carrying over, right? We're going to make our 10, take away the 2. And then we need to add the 3. Add the 1. So we add the 1. So my final answer is 31. Count of abaci. I'm just call one more. Wait, I'm just gonna call more than one as a count of abaci. I don't know. Oh my God, right? It makes so much sense. Here, it gets even better. It gets even better. This, when I was breaking this down, I was like, this is so much sense. So in mainstream math, I need to find really nice pen. So in mainstream math, hold on, Starship Enterprise, hold on just a minute. Let me finish my thought, and we will continue on with the adding and subtracting. So here in mainstream math, what do? In mainstream math, you have 23 on the abacus, right? 23. What happens? They have to cross this out, and they have to carry this one, and then they have to make this a 13. So that means what? You're going to have to memorize what? You're going to have to memorize that to make 13, it's a 9 and a 4. Don't feel dumb. Hold on, Starship. Hold on. I have a thought. I want to finish. So does that make sense? So in mainstream, what do? Is they have to memorize that 9 and 4 is equal to 13. But in abacus, we just need to know 9 is equal to minus the 10 plus the 1. That's all we got to do, because it's this 9 that we have to make sure. So we do minus the 10 plus the 1. And then take away the 1. So my final answer is 4. Hold on, Starship. Hold on. Does that make sense, Hannah? So when we're looking, we have, again, we want to do 35 on the abacus. 1, 2, 3, and then 5. The top beat is always 5. So when we do it, we're in mainstream, there's a carryover, right? A borrowing. So we have to add the 15, make it a 15. But guess what? You're going to have to memorize 9 and 6 is equal to 15. I don't want to memorize that. That's a lot of memorizing. In abacus, we just need to memorize 9 is equal to minus the 10 plus the 1. Right? Why? Because it's this 9 that we need to figure out. It's the second number. We're not looking at the result. We're looking at what the process is. So we have 35. I want to minus the 9 is minus the 10 plus the 1. And then I can minus the 2. So when I minus the 2, my final answer is 6. Thank you so much, Hannah. I do appreciate that. So we could do it again here. So in mainstream, it crosses out and they trade it in to borrow. So then the number is 16. But then you have to memorize 9 and 7 is equal to 16. Whereas on the abacus, if I have 8 and I have 6, I just need to minus the 9 is equal to minus the 10 plus the 1. This is the formula. So the formula is what? Minus the 10 plus the 1. And then we have to take away the 5. Take away the 5. So my final answer is 27. We are not looking at the result. We're looking at the process. Right, yes. We're looking at the process. And that's the crazy thing. Thank you so much for the comment. Yes, we are always looking at the process. It is this number will dictate whether or not we need to add or subtract or use a formula. So we could do it again. We don't want it, so we can do it here. We do 47. So we have 40. 1, 2, 3, 4. Anytime the beads are touching the reckoning bar, this is the reckoning bar, it is being counted. So if this is being counted, we have 2 columns counted. 1, 2, 4. 1, 2, 3, 4. This is 7. 5, 6, 7. These 2 are being counted. What I want to do is I want to take away 19. Take away 1, take away 9. Take away 1, take away 9. Again, minus the 9 is what? Minus the 10 plus the 1. So I'm going to take away the 10 and then plus the 1. And my final answer is 28. 28. 8. Absolutely brilliant. This could totally help my students who... Yes! Yes! You know, funny! You know what's really funny? What's really funny is that Abacus was introduced for the ESL, or not ESL, for the special, for accommodations, or it's introduced as an enrichment program. And I'm like, well, the average people need to know what an abacus is. And I am here to introduce Abacus to the Matrix. Thank you, everybody, for joining.
Welcome to the real world.
Thank you, everybody, for joining. Okay, so this is geometry. I think I see triangles. I don't know if these are triangles. Oh, I guess you see triangle here if you add it. You could do that. Thank you for the... Okay, Starship, you're still here. Are you still here? Starship. Good. I teach 7th grade math and struggled with the basics. Yeah, it's really crazy. But if you could visualize it, it's so much easier. So much easier if you could visualize it. Oh, good. So we're going to count and do a little review. Are we ready? We're going to do 1, 2, 3, 4. Does that make sense? So anytime the beads are touching this horizontal bar, this reckoning bar, it's being counted. So when we're looking, we have 0, 0. These are not counted. These are not counted. So we're only looking at this one right here. Why? Because these are the only ones touching the horizontal bar. So when we're looking, we have 4. 1, 2, 3, 4. We have 5. The top bead will always be 5 no matter what. The top bead is always 5. Then we have 6, 7, 8, and then 9. Starship, does that make sense? So when we have 9, we can do 10. 10 looks like that. Why? Because every column is a place value. So we have our ones, our tens, our hundreds, thousands, and 10,000s. We have decimals. So between the ones and the tenth is the decimal. Then we have our tenths and we have our hundreds. Ha, Michael, you like my matrix? I am here to introduce Abacus to the matrix. I'm here to introduce the matrix, what an abacus is. Starship, did that make sense? Okay, good. And that's it. All we're doing is learning how to read the abacus. But then what happens is what I was talking about, this here, these are what we call formulas. And when we start talking about formulas, that's what this book comes in. We start talking about formulas. The formulas is what? If I want to add the 4, right? All I got to do is add the 4. Right? I want to add another 4, but I don't have enough beads. I don't want to do this because this is 4, 4, right? Because this is 4, 4, this is 44, I don't... Oh, thank you, Ian. Right? So when we're looking, I would have 4. We don't want to do this. We want to do is we want to add the 4 here. We're doing 3. We're doing 3. We'll do 3, right? 1, 2, 3, 4, 1, 2, 3, 4. That's the 4. We do 3. To add the 3, what do? We don't have enough to add the 3. Guess what? I have a nickel. This nickel is going to help us. Why? Because we know how to make a 5. How do we make a 5 with a 3? We know 3 plus 2 is equal to 5. We're going to utilize this 5. That's what this is. This is the 5, right? But that means what? That's too much. I need to take away 2. Take away 2. So my final answer is 7. 5, 6, 7. I can do it again with my abacus. I can add the 5, take away the 2, and my final answer is 7. Starship, did that make sense? Thank you, Ian. Ian, did that... Oh, Ian, I'm hoping that makes sense. Right? So what did we just do? We substituted the 3 for this formula. The formula is plus the 5 minus the 2. And we could do it again. We could do it again with the 3. We're not going to memorize 3 plus 3. What we're going to do is we're going to understand the concept of how to make a 3. We're not looking at the result. We're looking at the process. We need to know the process. We need to know what this number does, right? So when we're looking, we want to add the 5. Because I don't have any more beads to add the 3. What are we doing? Well, we got to add the 5. Take away the 2. So my final answer is 6. 5, 6. We could do it again. 5, take away 2. So I could do it. I could show you another way. I have 4 in the abacus. Let me do another one. I have 4 in the abacus. 1, 2, 3, 4. 1, 2, 3, 4. Right? I have this package of 5. 1, 2, 3, 4, 5. It's stuck together. It is glued together. Because it's glued together, what am I going to do? I don't want to break it. It looks too pretty to break. So what can I do? I'm going to take this away because this is a loose bead. So I'm going to take it away. That's what I got to do. Take it away. And then I'm going to add the 5. So my final answer is 8. 5, 6, 7, 8. 5, 6, 7, 8. That's what I did. Thank you so much for sharing my live. Thank you so much for sharing my live. Right? So what are we doing? We're understanding concepts of the process, not the result. We're not focused on the result. We're focusing on the process. The process is, can I add the 4? That's it. That's it. Can you? Why do I want to say that? Okay. Does that make sense? So good. So we could do it again with the 3. We have 3 on the abacus, right? 1, 2, 3. 1, 2, 3. 1, 2, 3. And then we want to add the 4. To add the 4, what are we doing? To add the 4, we're going to utilize this 5. To utilize this 5, I have the 4 in here. 1, 2, 3, 4. I need to break apart this 1, but it's too much energy. I don't want to, I'm too lazy. So I don't want to do that. So what I want to do is I want to take it away from here. I can take it away from here. So my final answer is 7. So I can add the 5 and take away the 1. It's late. I'm having a great time. It's so late. How late is it for you? Hello, Mexi Mander. Welcome back. It's so funny. I have East Coast people coming in and they're learning how to do the abacus, and it's really late, like at 3 in the morning. It's so crazy. It's so crazy. It's so crazy. I know. This is like midnight math for Hannah, right? It's nuts. It's nuts. But I do appreciate you stopping by and seeing what this is all about and keeping your mind open.
Oh, I love it. Great stuff.
Are all abaci set up like this? No. No. There is this one. There is this one. And there's this one. And there is this one. And then there's like others. Okay, there's a 10 bead one. This is a Chinese abacus. This is a rendition of a Chinese abacus, but it has, it just looks kind of Japanese. And then this is the Japanese abacus, and then that's it. So what is it? It looks exactly, it uses the similar, it's very similar. We can count 1, 2, 3, 4, 5. 1, 2, 3, 4. But then we have 5, so we have to trade that in, right? So that's 5. We could do 6, 7, 8, 9, 10. Now we have 5. Because we have 5, we have to trade that in. And now that's 10. But then because this is 10, we got to trade it in. JC, did that make sense? I want to see if you want to think about it you're here tonight. Okay, yeah. We could do that. So, JC, does that make sense? So when we're looking, we have 6, 5, 6, 7, 8, 9, and then we have 10. Japanese came back and they made the Chinese abacus more efficient. So that's why we don't have extra beads in the Japanese abacus. But in the Chinese abacus, it was around a little bit longer. There's another set called there's a 10 bead one that's either Russian, Reckon Rec, Right Start, Right Start. Yeah, I think those are the old ones. And then there's a Kramer one. A Kramer one is very similar to the Japanese abacus, but it's just harder to move. Top is usually increments of 5. Yes, JC. The top one is usually increments of 5. So when we do this is 5. And it's crazy. Hannah, this is so cool. When we look, we could do 6 times table on the Chinese abacus. 6 times 1 is 6. Let's do that. 6 times 1. 6 times 2, all I got to do is add another 6. And I get 12. Because I have 10 here, I'm going to change that in. So that's 12. 6 times 3, 5, 6, 7, 8. That's 18. 6 times, let's do it again. 6 times 4 is 24. So I'm going to do that. And then 6 times 5 is 30. This is crazy. It was so crazy. When I found this out, I was like, oh my God, the 6 times table is so easy. 6 times 6, right, is 36. I'm just adding 6. 6 times 7, 42. 6 times 7, 6 times 8. Add in there. It only works with the 5 and the 6. It doesn't work with 7. It only works with 6, which is funny. It doesn't work for 7s, because we have 7, 7. Well, actually, I don't know. 7. Yeah, see right here, I can't add a 7 because I have 5 and I have 6. I cannot add 7, so that's where it breaks down. You can only do the 6 and the 5s. Yeah. Anyways, I didn't know I loved math more than I already did. I know. The abacus makes it so much easier. It's so crazy. It's so crazy. So 2, 4, 6. No. See, you still need formulas for that. 6 and 5 is, I think, the only one that you can do. Okay. So, that's right. But that's just doing increments of 6. Okay. So, how are we doing? I've been on. Okay, how are we doing? Thank you guys, everybody, for the likes and joining. Please. This is.
Oh, I love it. Great stuff.
All right. One bottle down. I always try to figure out how many bottles of liquid I can drink. All right. So everybody who is here, thank you so much for joining. My name is Lynette. We are learning how to read the abacus, and I do have it available over here. This is a 7-column abacus, and this abacus just tells you what the numbers are. That's all it does. It just tells you what the numbers are. And if you notice, the beads are very easy to move. This is simple to use and easy to understand. Let's do a little review. We're going to count 1, 2, 3, 4, and then we have 5. The top bead will always be 5. So we have 5, 5, 5, 5, 5, 5, 5. That's what 5 is. Notice that we are only counting the beads that are touching this reckoning bar. So this is 5, and then now we have 6. Notice these beads are not touching the reckoning bar, so these are not counted. These are all zeros. So we have 5, 6, and then 7. 5 plus 2 is 7. 5 plus 3 is 8. And then 5 plus 4 is 9. After 9, we have 10. How do I know? Because every column is a place value. So we have our ones, our tens, hundreds, thousands, and 10,000s. Thank you, Odyssey. Thank you so much for checking in. For those of you, thank you so much. Thank you, Odyssey. I do have a gift. Thank you so much. Thank you for the follow. For those of you that are interested, go ahead and check in on the orange heart. That's where my head is. Okay. Yes, thank you so much for the gift. Okay. How are we doing? For those of you that just joined, we can do a little review. Thank you so much. Please keep your mind open.
Now open your mind to me, please. Open your mind.
All right. And then we're going to do something really quick, which is multiplication. I'm going to show you multiplication. Okay. So, Hannah, you know distributive property, right? Yeah. Okay. So in Abacus world, that's all we do, is we do distributive property. Now, I've had a couple of people, I had one person come in and say, this is not how you do distributive property. Distributive property, for those of you who don't know, is just taking the number and breaking it into smaller parts. That's all we're doing. So when we're doing distributive property, we'll do this number. So here, when we're looking at it, distributive property only means that we're going to times this number with this number, and then we break it up, we times the 3 with the 7. That's all we're doing. That's what distributive property is. Again, it's another maze. So, again, on the abacus, the first thing we're going to do is we're going to understand where we're going to put our number. We're going to put our number 3 digits. Why? Because we know in our question that we have 3 digits. 1, 2, 3. So we don't need to worry about it. We know we're going to be 3 digits. We're going to be over here. So when we're going to do it, we're going to have 3 times 4. This is part of distributive property. We do 3 times 4 is equal to 12. Notice I say 3 times 4 and not 3 times 40. The reason why is because the abacus keeps track of our digits. All I got to do is put 12, 1 and 2. Notice it says 120. When we translate it from abacus to abacus to paper, we don't need to worry about the place values. Whereas mainstream, it's all on paper. You need to track you need to track where the digits are. So in mainstream, you say 40 times 3 because you need to know and track your place values. But in abacus, we don't need to. So then our final one is 3 times 7 is equal to 21. I add the 2 and then I add the 1. So my final answer is 141. And that's it. 141. That's all we're doing. Yeah, distributive property. And it's amazing because the abacus tracks your numbers. Right? That's what I'm saying. Because in mainstream, we have to track it ourselves, right? Where is paper? Where is paper? Oh, here it is. Right? Mainstream, what happens? We did 47 times 3. So mainstream, what happens? You got to do 21, and then what? You got to bring down the 0, and then you got to do 2, and then 1. There's a new one, right? There's a new one. They did what? 47 times that by 3. Then they do 3 times 4. 40 is equal to 120. And then they do 7 times 3 is 21. So, I love... Why are we starting at the 5 beats? Love it. You are my people. Thank you, Hannah. The hundreds and the... Oh, yes, thank you. Yes, thank you, JC. Thank you, Odyssey. Yes. So when we're looking, why are we here? Because when we're looking at our question is 3 digits. We know we're going to be in the hundreds. Does that make sense, JC? So 1, 2, 3. We know the question, and we know the answer is going to be somewhere in the hundreds, no matter what. Somewhere. Kind of, feeling it, right? So it's going to be somewhere. So we don't need to blindly look at our numbers. What we're doing is we're critically thinking imagining what our outcome is going to be. That's why we start at the 5th column. We started here because this is my ones. If I have this, these are my decimals, my tenths, my hundredths, my tenths, and I start from here. So then I know, because I have 3 digits, I know I'm going to be somewhere in the hundreds. Oh yeah, not a problem. Thank you so much, JC, for the question. So we do 1, 2, 3. That's what we did. So then we do it again. Hello, Chin Fu. Hello. And again, right? And that's the thing. The thing is mainstream, they don't critically think what the questions are. They just kind of say, just do it. Whereas in abacus, we kind of look at it like, this kind of looks like it's going to be a 3-digit number, right? So we're going to try it. 1, 2, 3. So let's do it. We do 9 times 2. 9 times 2 is 18. Add the 1, add the 8. And then 9 times 1. 9 times 1 is equal to 9. Well, guess what? 9 is a single digit. Because 9 is a single digit, we need to make this a double digit. This double digit is a 0 and a 9. That's how we make it a double digit. So it would be a 0, which will push us to the next column over, and we add the 9. So my final answer is 189. Yeah, 189. Thank you, Puddle Water, for the follow. Thank you so much. I appreciate that. So our answer is 189. There we go. 189. All right. So thank you everybody for joining. Thank you everybody for joining. For those of you that just joined, we're going to do a little review. Here we go. Let's talk about what the abacus is. This is a counting tool. All it does is just tells me what the numbers are. That's all it is. It's such a simple thing. It just tells me what the number is. So when you're looking, the beads are very easy to move. Because the beads are very easy to move, you want to use your left hand to stabilize it. So let's do a little review. We're going to count. Anytime the beads are touching this reckoning bar, this is what's being counted. So when we look, we have 1 and this is 2. None of these are touching the reckoning bar, so none of these are counted. This 5 is not counted. We're only counting these 2. So then we have, hey, LMGS. Oh, yay! You got your abacus in the mail today. Oh, yeah. So then you can start doing this with me. Okay, have a good night, Hannah. Can we try a higher number? Yeah, we could try. Hold on just a minute. So we have 3, 1, 2, 3, 4, and then we have 5. We have 6, 7, 8, and then 9. After 9, we have 10. 10 is a 1 and a 0. We have 20, 30, 40, and then 50. We have 60, 70, 80, 90. Paulo, when you ask for a higher number, are you asking what 9999999 is? Is that what you're asking? That just looks like this. I saw a video doing large numbers of multiplication. Yes. And they're doing imaginary numbers in their head. Yes. Yes. I've ever experienced I wanted to learn the others. Oh! Well, welcome to my room. So we have 99,999.99. Is that what you're looking for, Paulo? What are you asking? Higher number. All right. So that's it. I mean, that's everything about, oh, I like multiply 4 digits by 4 digits. We can, but it might get confusing. Oh, thank you so much for the gift, Odyssey. We can. Just don't complain if it gets too complicated. We're going to do it? You're amazing, by the way. Oh, thank you so much. Oh, thank you. Thank you, Odyssey, so much for the Pharaoh mask. Okay, we can do it. Not a problem. But don't complain. Don't complain if it looks complicated. I'll go slow. All right, let's see. Where's my other abacus? Okay, here we go. If I make a mistake, then I'm gonna chalk it up as I'm very tired. All right, so we'll do 4, 7, 2, 3 times that by 6, 5, 4, 9. All right. Distributive property. Again, when we do distributive property, we got to go one number at a time. This is going to be a while. What are we doing? How many digits are we doing? You let me know. How many digits are we doing? Do you know? It's the same thing. The concept is still the same. We still need to count the amount, right? We count 8. 1, 2, 3, 4. Yes, LMGS. Yes, 8. 4, 5, 6, 7, 8. Yes, it will be 8. Somewhere around 8. So I'm going to call this one as my ones. And I'm going to count it out. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to be somewhere around here. So we're going to do 6 times 4 is equal to 24. Add the 2, add the 4. 6 times 7 is equal to 42. Add the 4, add the 2. I'm totally missing some formulas. Adding the 4, there's not enough. What do? We have to plus the 5 minus the 1. That's what we did. Plus the 5, take away the 1. And then what? 6 times 2 is equal to 12. So we add the 2 1, and then add the 2. And then 6 times 3 is 18. Add the 1, add the 8. We are done with this. We got to recount. We have 7. 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4, 5, 6, 7. 5 times 4. 5 times 4 is equal to 20. Add the 2. Plus the 10 minus the 8. Add the 0. Don't forget the 0. 5 times 7 is 35. Add the 3. There's not enough. Add the 3. Plus the 5 minus the 2. Add the 5. Right? Because we did 35. 5 times 2. 5 times 2 is 10. Add the 1. Add the 0. Add the 1. Add the 0. And then 5 times 3 is equal to 15. Add the 1. Add the 5. All right, we're done. We've done this. We're now up to 4. So when we're looking, we have to count it again. 1, 2, 3, 4, 5, 6. So we do it. 1, 2, 3, 4, 5, 6. So now we're here. 4 times 4. 4 times 4 is equal to 16. Add the 1, add the 6. To add the 6, there's not enough. I need to plus the 10 minus the 4. And then what do? 4 times 7 is 28. Add the 2, add the 8. Add the 8 plus the 10 minus the 2. 4 times 2 is 8. 8 is a single digit. I go back one column, I add the 8. Plus the 10 minus the 2. Minus the 2 is minus the 5 plus the 3. 4 times 3 is 12, plus the 1 plus the 2. We're almost done. All right. 1, 2, 3, 4, 5. Thank you so much, Chin. 1, 2, 3, 4, 5. What are we doing? 9 times 4 is equal to 36. Add the 3 plus the 10 minus the 7 and then plus the 6. Cannot plus the 6. Plus the 10 minus the 4. Whew. 9 times 7 is 63. Plus the 6 plus the 3 plus the 6. Cannot plus the 6. Plus the 10 minus the 4 plus the 3. Plus the 3 is plus the 5 minus the 2. 9 times 2 is 18. Plus the 1 plus the 8. Cannot plus the 8. Plus the 10 minus the 2. And then, finally, 9 times 3 is 27. Plus the 2 plus the 7. I think this is my answer. Please check. 3, 0, 9, 3, 0, 9, 2, 7. I think so. I don't know. I'm a little tired. I think that's the answer. I gotta check. Now I gotta check. Let's see. 4, 3, 2, times that by 6, 5, 4, 9. Oh yeah! I'm right! There you go, Paulo. Freestyling math. Did you get it? So yeah, I mean that's why I would get the 13 column abacus, because you can do longer division. That's the reason why. I was never good at math. You know what, Kat? If you did the abacus, you'd be great at math, because I'm not good at math. Let me tell you. So let's go back into the beginning, because Paulo, good job. I've never been able to understand this. Did you understand it now, Chinfu? Okay, so Kat, I don't know, Kat, were you here for this? Let's do a little review. Thank you so much for dropping by. Thank you so much for being patient. I was just working on a question. So we're going to count. We're going to do 1, 2, 3, 4, right? Notice that anytime the beads are touching the horizontal bar, that's what's being counted, right? So when we're looking, thank you, JC, for the follow. So when we do 5, 5 will always be the top bead no matter what. 5 is always the top bead. So if we do 5, 5, 5, 5, 5, 5, 5, this is what 5. So we look at this is 55. How do I know this is 55? 55 because these two beads are touching this column. So when we're looking, I don't know. Oh, here it is. We have our place values. Hey, Trey, welcome. So we have our place values. I have our ones, tens, hundred thousands, 10,000s. So when we have 5, what's after 5? 6. Well, how do I know? Well, 5 plus 1 is 6. 5 plus 1. 5 plus 2 is 7. 5 plus 2 is 7. 5 plus 3, 1, 2, 3 is 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then what do? We have 10. 10 is 1 and a 0. This is not 10. This is 55. This is 10. Does that make sense, Kat? How you doing? Yeah. Thank you for joining, Kat. I do appreciate that. I'm hoping that the abacus does not scare you away. Right? Makes sense. Good. Good. Yeah. And that's the thing, like my whole goal is to make math fun but also kind of interesting. So if you enjoy Sudoku, word searches, crossword puzzles, all that stuff, you're going to enjoy the abacus. Because the abacus is kind of like keeps your mind active as well as doing arithmetic. So if you like jigsaw puzzles, word searches, crossword puzzles, Sudoku, oh you can't see that, chess or logical puzzles, you will enjoy the abacus. I do. I like puzzles. So on the abacus, does this work for division? Yes, it does. Are we ready for that? For those of you that are interested, I do have books available. I have adding and subtracting books available on my over here or in my TikTok shop. I do have it available. I do have a full collection here, but I'm starting to build out my TikTok shop. Hello, depressed frog. Oh no, it's interesting to do division, but you can do division on the abacus. You know, because really it's just it's the process. The way we do division on the abacus is finding the finding the missing multiplication fact. We could do it. We could do it. We could do it. Let's see. How are we doing? Kat, you all right? So when we're looking, we have 9, and then we have 9. So this is 99. We have 999, and then we have 9,999. So, and then you might be wondering, well, the decimal sits between the ones and the tenths. So the decimals are right here. So when we're looking, we can do $2.25, right? Because that's what the decimals are. If you notice, we do have this one, right? There's a label. This is a label. And if I choose, notice that there's this one here. This one is like my thousands, like a grouping. So we have my ones and my thousands. It's nice to see because then I know where my thousands are. And it's easier to see, just like this. This is grouping. So I have my ones, thousands, millions, billions, and trillions. It's easy to see. That's why I find it very interesting and informative. I'm addicted to playing chess. Oh, yeah. Yes. And it's interesting because there's enough information, but you still need to think. You know what I mean? If you want to do it the abacus way, but you still need to kind of think. And it's interesting. I did this a little fast, but you need to know formulas. You need to know how to make a 5 and you need to know how to make a 10. If you know how to do any of these two, then you can do anything. Yep. Okay, so, Kat, are you still here? So when we're looking, okay, what are we doing? Okay, so you'll know that I can subitize. Subitizing means that if I add the 5 and I add the 3, I know that this is 8. I can count it. I don't need to count it. I don't need to say 5, 6, 7, 8. I can look at it and be like, okay, that's 8. But then what I could do is I could say 50 plus 30, 1, 2, 3. And then my final answer is 80, 8 and a 0. How can I see it? Because I remember that every column is a place value. We have our ones, our tens, hundreds, thousands, and 10,000s. There we go. Thank you, guys. Thank you, Odyssey, so much for the gift. Okay, how are we doing? We're all right? Okay. Let me find a division. What am I doing? All right. What are we doing? We gotta put this away. Oh no, we gotta keep this out. Okay, this is gonna be simple because I want to explain. What am I doing? I want to explain the concept. That's what I'm doing. I'm explaining the concepts. So we'll do this one. Nope, not that one. Sorry, excuse me. Let's see. There we go. Nope. Okay. Excuse me. Okay. So here's the concept. Let me talk about the concept. Easy. 98 divided by 2. What we're doing is we do long division. We in Abacus World do long division. And so when we're looking at it, we want to, we still need to count. We need to count, thank you, 300. It's because I pick on the trolls. Yeah, no. Okay, so what do we do? Okay, so when we're looking, again, we have to look at our question. When we look at our question, we need to understand what we're trying to do. So the first thing we're going to do is we're going to understand where we're going to put our answer. Where are we going to put our quotient? Our quotient's going to be at 1. Why? Because we have 2, 1, 2, 2 dividends minus 1 divisor gives me 1. So my place value, my quotient will be at the ones place. That's just something that we have to know, right? Because again, it goes back to understanding where we're going to put it. So because I know my quotient is going to be at the ones place, I'm going to put my dividend on the abacus. The dividend on my abacus is only a placeholder. So now what are we going to do is we're going to compare. No, we're not. We're going to multiply this out. What we do is we do 2 times what is equal to 9 or less. Well, because I can do this, I need to skip this question. I need to skip this column and go over here. So my question is 9 times 4 is equal to 8. 4 is part of my quotient. I'm going to add it to my abacus. I need to minus the 8. So I take away the 8. And now what am I going to do? Well, I have my 1 over here. So my question goes back to 2 times what is equal to 1. Well, there is no multiplication fact that says this. So that's the reason why I have to bring down my 8. So I have to actually do 18. I have to make it 2 digits. So now my question goes, 2 times what is equal to 18 or less? 2 times 9. So I add my 9 on the abacus, and I take away 18. Take away 1, take away 8. So my final answer is, my final answer is 49. So my final answer is 49. That's division. I don't know if that made sense. Because what are we doing? We're looking at how to do multiplication in reverse. And we do subtraction. Yep. That's it. That is how you do division on the abacus. Hi, Eve. Oh, I'm so late. Eve. You want to do another one? So much sense. Yeah. Eve, you're so funny. All right, let's do it again. Let's do another one. I don't get to do division very often, but everybody seems to be tracking, so it's been good. Okay, let's do another one. Oh, excuse me. Okay. Okay, we'll do this one. Again, we'll do it. We'll do something simple. Visualizing would be so much easier. I know. That's so crazy. It's so. That's what I'm saying. This thing doesn't do nothing. It just tells you what the number is. But because we can see the number, you can do so much more. It's so crazy. It doesn't do any calculations. If you notice, these are all the calculations you do in your head. And that's why this will help deter dementia. That's why it's fine to use a calculator. Go ahead and use a calculator. But if you can use the abacus, it keeps your mind active. It's like brain gymnastics if you're interested. It's so cool. It's so cool. Okay. So it could also be that my numbers. Okay. Who is my? I don't have a mathematician that I know of. I honestly don't. Actually don't know any mathematicians. I don't trust that. I'm so. Raman. No, I'll have to check that out. Thank you, Cool 5. I will have to check that out. Ramanu Juan. Hello, Sammy. How's it going? Okay, so Eve, are you here? Thank you for the follow. Okay, remember our dividend. Remember our dividend? Do you remember how to do it? We have to find our place value. Harry Houdini. Harry Houdini is a mathematician? I didn't know that. I will have to look that up. I didn't know Harry Houdini was a mathematician. These are great. Thank you guys so much. I'm actually reading some math books. It's interesting. It's a little bit over my head. It's a little bit above my. Oh, I know he's a magician. You're so silly, Ellen. You got me. All right. Okay. So what are we doing? When we're looking, we need to look at what? 1, 2, 3. We know there's going to be 3 digits in our dividends. Take away 1 digit. So we know what? It's going to be in our 2 place value, right? 2. 1, 2. I'm going to be here because I want to put my numbers here. So 2, right? There we go. Right? Dark Star, he could be a mathematician. All right. So we have 2, 1, 2. We're going to put our dividend here. 1, 4, 8. So now what are we going to do? Well, we have to figure out our multiplication. We got to figure out 2 times what is equal to 1. Minus the 1, minus 3. 1, 2, 3. Sammy, it could help you with math. It just depends on what kind of math it is. Eve, does that make sense? We have 3 digits in our dividend. Okay, so when we're looking, we're going to do multiplication. But notice I don't have, this is never part of the multiplication table. So we need to bring down our number. What number are we going to bring down? Four. Yes, thank you. We bring down the 4. That's the same color. Yes, we bring down the 4. Why? Yes, LM. Yes, we bring down the 4 because we want to make it 2-digit, and the 4 happens right here. So my next question is 2 times what is equal to 14? 2 times 7. 7 goes here. 5, 6, 7. So I take away 1, take away 4. And then I'm left with this. So I'm going to put my answer here. My next question is 2 times what is equal to 8 or less. Because I can do this, I'm going to skip this column and I'm going to go over here. Because I can do this, I'm going to skip this column and I got to go over here. So 2 times 4 is equal to 8. Add 4 to my quotient. Take away 8. Take away 1. Take away 8. Hey, Jello! Welcome! Yes, thank you. Handu. Yes, 7 and 4. Thank you, thank you, thank you. We were just doing some division. I was just explaining to the students. I was explaining to the kids. Hey, Jeremiah, welcome! Welcome, Jeremiah. Yeah, I was just talking about division. Hey, Jello, what do you call when it's too much? Thank you. D. Thank you so much, D. When you do division, Jello, what do you call it when it's too much? I need to learn more. Okay, hold on just a minute. You know what I'm talking about? Jello, a remainder? No, not a remainder. Like, let me, hold on. Let me see if I can find a division question. Oh, where am I? Hold on. I need to find this one. Hold, please. So when you do, when you put when the quotient is too much, too much of quotient. Hold on. Where are you? There we are. Okay. So if we did here. If you did this one, 59,776. So when we do it, right? Okay, 5 times what? Okay, now this is getting... I wonder what they're calling it, is what I'm asking. It's 6. Is it 6? Yeah, but see, if we said 6... No, it's 7. Because 5 times what is equal to 37. So it's not 6, it's 7, right? Because it's... Oh, wait. 1, 2, 3, 4, 1, 2. I should use the other abacus. 2. So we do 3, 7, 7, 6. So we do 7, right? 7. Take away 30. Take away 5. That's too much. So when you say too much, yeah, but don't you say, yeah, you don't do 7? How do you know that 5 and how do you know that 6 times 5? How do you know that 7 is too much? Do you not do that? That's interesting. Yes, because 7 is the closest to 35. I just do 7 and it's bigger. Yes, it's closest to. But then what do they call it is the question. What does your school call it? because then there's a whole process, right? The whole process is it's too much. So what do we have to do is we have to go back, take away 1, and then add the dividend. So then we're back to this. So then it's 5 times 6 is equal to 30. Take away 3, take away 0. We don't call it anything? Really? Rounding to the nearest whole number? No. It's not rounding to the nearest whole number. There's a whole terminology that in Abacus world we talk about. And so Jello actually knows. I've been out of school for like 8 years. I forgot all the terms. No, but this is different. Wait, I could show you something. Oh, yeah. Hold on. Yeah, that'd be great. Let me see if I can. Come on. Hello. That is. Yeah. Hold on. Report. Yes. Hello. Hi.
Hey.
You don't call it anything?
No, wait, hold on. Can I turn on my camera?
Oh, I don't know. Expand.
Oh, it doesn't let me do that.
Shrink, disconnect. I don't know. I just expanded
Oh,
you. But you have to turn on your camera. You can't turn it on?
but it doesn't let me.
Oh, no.
Oops. I got my abacus too.
I don't know how to do it. Oh, you know what? Maybe
It says I need access to go on video.
How do I do that? Sorry.
It's okay.
Let me see if I can. Reply. I can add you as a moderator. No, I don't want to add you as a moderator. I want to add you as a. Going live. Oh, here we go.
Yeah?
I don't think so.
Got
History. Hold on. Let me disconnect you. Let me see. Okay. Multi-guest. Invite. Jello. Send. So, did that work?
No, I need more followers.
Okay. Oh, I see. Jeremiah said, yeah. Oh, I'm sorry. You can go live individually and then add her.
Yeah, I can't go live individually.
Oh, okay. You want to try to walk me through it?
Okay, yeah, so there's 776, and then you do 7 times 6 is,
Wait.
5 times 6 is
Yeah.
30.
No, but see, that's
And
the
then-
question. How do you know it's 6 and not 7?
Because 9 times 7 is 63, and then it's too big. I don't know how to explain it.
So you do this. So you go all the way to 9 times 6 is 60. 9 times 7 is 63, and you know that you can't do it.
Yeah.
Oh, interesting. Okay. Yeah, cause what I'm trying to do is I'm trying to relate it to mainstream math, and mainstream math doesn't do that. You know what I mean?
Yeah.
Okay. So I know that doesn't make sense. Like, so you go, do you not go to 5 times 7 first? You go straight to 5 times 6?
Yeah, because I can do the mental. So my teacher just tells me to do it. Yeah.
Thank you, Jeremiah, for letting me know. Okay. Yeah, see, when I'm trying to teach, not everybody knows mental, so that's why I have to
Yeah.
break it down some more. So, but thank you so much. I do appreciate that you joined.
Yeah, thank you.
Okay, bye, Jello. Thank you everybody for being so patient. It's giving your phone permission to use the access to TikTok. Oh, yeah, yeah, yeah. All right. So, yeah, that's interesting. Okay. Yeah, trying to teach it as mainstream math is just one of those interesting things. Remember me? Hey, Sassy, I do. My school district does it that way too. I'm trying to learn your perspective. Your school district does it through the Abacus way? That's very interesting. This is different. This is different. So when we're doing it, I usually start from usually start from a simpler question, which is something like this. So here, what we do is we figure out where our starting point is. The reason why we figure out our starting point is that we know where to put our quotient. We use the cat. Oh, interesting. Oh, okay. I see. I see. Cat lover. That's funny. All right. Yeah, I won't be able to know. If you change your name, I won't know. So when we're doing this. Oh, Jello, I had another question. How do you figure out where to put your quotient? Do you do it the way I do it? Oh, I don't know if she's here. I've never used an abacus. I'm trying to learn through the abacus. Oh, I see. I see. I see. Okay. Jello? Oh, I don't know if Jello left. She probably got scared. All right. Um. Eve, where are we? Where are we? We don't call it anything. Round is the nearest number. Okay. So before we continue on, I mean, for those of you that just joined, thank you so much for being patient. What we're going to do is let's do a little review. We're going to review how to read the abacus. So we have 1, 2, 3, 4, and then we have 5. After 5, we have 6, 7, 8, 9, and then 10. Because we have 10, every column is a place value. So we have our ones, tens, hundreds, thousands, and then 10,000s. So after that, we have 11, 12, 13, 14, and then we have 15. Then we have 16, 17, 18, 19, and then 20. After that, we have 20. This is a 2 and a 0. So, okay, how are we doing? So, for those of you that just joined, what we're doing is we're learning how to read the abacus. Eve, I don't know if Eve is still here. Eve, are you still here? Are we going to continue on to do adding of the 5, right? When we add the 5, what are we doing? We're adding the 5. Let's see. Why are we adding the 5? Because that's the next thing we do. Because we need to understand concepts, right? So the concept is 4 plus 1 is equal to 5. Or 1 plus 4 is equal to 5. Or 3 plus 2 and 2 plus 3. This concept is what's going to be interesting. The reason why is because the abacus puts in a restriction. The restriction is what? If I have 4 on my abacus, I don't have enough beats to add another 4. So what's going to happen is what? I need to utilize something. Let me give you a little perspective. So we have 1, 2, 3, 4. This is different. This is different than mainstream. So when we're looking, I want to add this 4. I have this 4, 1, 2, 3, 4, 1, 2, 3, 4. That's what I have on the abacus, right? But then I want to add this 4. To add this 4, I don't have any more beats. I don't want to do this because that would be 44. What's going to happen is what? This is the wrong number. We need to add the 4 to the ones column. Because we're adding the 4 to the ones column, I'm going to give you the 5, but that's too much. I need to subtract the 1. So I took away the 1. My final answer is 8. 5, 6, 7, 8. So we can do it again on the abacus. Add the 5, take away the 1. So my final answer is 8. 5, 6, 7, 8. We can do it again. Bring the top down and subtract 1. Yes. The reason why is because, here, let me show you another way. Let me show you another way. If I have 4 on my abacus, 1, 2, 3, 4, right? I have 4 on my abacus. Now, I need to add another 4, but I have a package. This package, if you notice, has 5 bricks, 5 cubes. 1, 2, 3, 4, 5. Inside here is 4. 1, 2, 3, 4. So that means what? I need to break this apart, but it's all glued. Because it's glued, it's too much for me to take away, right? It's too much energy. I'm tired. I don't know, whatever, right? I cannot break this. So what do I do is I need to take away this 1. But to take away this 1, I can actually remove it from here. Does that make sense, Bailey? So if I take it away from here, that's what I did. I take it away from this 4. And I can add my package, my 5. So my final answer is 8. 5, 6, 7, 8. That's why we take away the 1. Bring down and subtract the 1. Yes, that's why we take away the 1. Because we want to keep this package as a whole. We could do it again with the 3. If I have 3 on the abacus, 3 on the abacus, and I want to add the 4, it's in here. My package has 4. 1, 2, 3, 4. I need to take away this 1 brick, this 1 cube. But I can't because it's all glued. So I got to take it away from something that's easier. So I could take it away from here. Same thing. Take it away from here. I add the 5 and I take away the 1. Yes, thank you, Paranormal Dad. Yes, the 5 is always the top bead. The top bead is 5. 5, 5, 5, 5, 5, 5, 5. Yes. And so the bottom beads is equal to 1. So this is 1. So we have 1, 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1, 1, 1. This is 2. 1, 2. This is 3. 1, 2, 1, 1, 3. And then this is 4. 4, 4, 4, 4, 4. Yep. Does that make sense, Bailey? Yeah. So when we're adding, we also understand that we have to subtract. We're balancing the equation. We have a little bit more than we do. It's like giving out change, right? We know how to give out change. It's the same thing. When we give out change, that's what we do. We give you a little bit more, but then you have to give me back some change. So that's why we do this. So if I have 2 on my abacus, 1, 2, I'm going to give you 5, but I'm going to expect some change. Because I'm going to expect some change, I need to take away the 1. Not to jump ahead, but how do you do multiply? You want to do that now? We can do that now. But thank you. I do appreciate it. Thank you for being considerate. We can do multiplication. I will show you. Thank you so much for being considerate. I appreciate that. So, that is about adding and subtracting. Multiplication is quite easy. Multiplication, do you know, it's called distributive property. Do you understand what distributive property is? Okay, good. So Abacus World, we do distributive property. Great. So when we're looking at it, this is what we're going to do. Distributive property. Distributive property means I'm going to take a number, I'm going to break it up into smaller parts. So I have 3 on my abacus. No, I'm going to count how many digits are in my question. I have 1, 2, 3. 1, 2, 3. So because I have 3, I don't need to think about anything else. I just need to know where to put my number. The reason why is because I'm not going to say 3 times 20. I don't need to say 3 times 20. I just need to say 3 times 2. 3 times 2 is equal to 6. 6 is a single digit, so I need to make it a double digit. So I'm going to do a 0 and a 6. The 0 is my placeholder. I'm going to add the 0. I'm going to put the 6. That's where my 6 is. My next number is 3 times 7. 3 times 7 is equal to 21. So I add 20 and I add my 1. So my final answer is 81. The more you know. Yes.
Now I know.
And knowing is half the battle.
Okay. So, okay, let's try that again. So my final answer is 81. That's what this is, right? I thought yellow was 2. No, yellow is not 2. Yellow is 1. This is a value. So this is why I don't jump ahead to multiplication. So when we're looking, we need to understand how to read the abacus. So if we have 1, 1, 2, 2, 3, 3, 4, and then 4. What do? We do 5. This is the value of 5, right? This is the value of 5. If we do 6, we have 6. We have 7. This is 7. This is 8, 8, and then 9. We have 9. So when we're looking, because multiplication is what? Multiplication is just fast adding. So when you're looking, thank you, Peachy, the colors mean nothing. The colors mean nothing. The colors is just actually what it is it just looks pretty. It's the positioning of the beads. So when we're looking, this is 0. These are all zeroed out. When we're looking, this is 1, 2, 3, 4. And then this is 5. This is 5. We have 6, 6, 7, 7, 8, 8, 9, and then 9. We have 10. When we look, this is 10. And then what happens? When we want to add, we have 11. We want to add 6. To add 6 is plus the 5 and the 1. We bring it together like this. This is adding the 6. So then you look to the left to right. You look at it left to right. Yes. So when we're looking, it's just like reading the numbers. What are the benefits of using the abacus? Keeps your mind, it's like brain gymnastics. Keeps your brain, it keeps your brain active. It's like, working with Sudoku, working with chess, working with word searches. And so they were talking about how doing Sudoku helps deter dementia. I believe abacus will do the same way because we keep our brain active when we start doing adding and subtracting and multiplication and division. Thank you, Azaria. Thank you so much. Exercise for the brain. Yes, thank you, Michael. It's exercise for the brain, like brain gymnastics. So when we're adding 2, we want to add these 2 beads. That's what we're doing. So you leave the 2 on the left. Yes, you're absolutely right. We have decimals. If I had my hammer, no, there we are. So we have our decimals. You're absolutely right. So when we have it, we have our ones, our tens, our hundreds, our thousands. This is our tenths. So because we have our ones, we have our tenths, and we have our hundreds. Our decimal sits between the hundreds and the tenths. I'm sorry, the ones and the tenths. This is where the decimal sits. It doesn't take a place value. It doesn't take a placeholder. So this is our tenths. So 45, 0.45. Can you show 11? Yes. So 11 looks like this. That's what 11 is. 1 and 1, just as you wrote it, right? 1 and 1. If I want to add 7, I add the 5 and then I add the 2 beads and I bring it together and I add 7. That's what 7 looks like. So our final answer is 18. If I add the 1, that's all I'm doing. I'm adding the 1. My answer is 19. We're looking at the process and not the result. Thank you, Jeremiah, for checking in. For those of you that's interested, please check in the orange heartbeat. Okay, so when we want to subtract, I want to subtract 8. So if I subtract 8, I move 5 and then 3, and I move it away like that. So my final answer is 8. So my final answer is 11. So what did we just do is, when I know how to add, I go to the horizontal bar. When I subtract, I go away from the horizontal bar. So I add, I go to the horizontal bar. I subtract, I go away from the horizontal bar. So my final answer is 11. Hey, Michael, thank you so much for checking in. How are we doing? So when we look, yes, I usually... That's N. Welcome. It's like a calculator. You're right. It's like a display. That's all it is. It's just a display. But you do the calculations in your mind, and that's what it is. Hello. Hello, that's N. This is great. Thank you. Thank you. Thank you for joining. Thank you so much for keeping your mind open for something different.
Now open your mind to me, please. Open your mind.
Thank you everybody for joining. Thank you everybody for joining. I am here to show the matrix what an abacus is. And an abacus just tells you what the numbers are and visualizes the number. So what we're doing here is we're looking at the number 11. And then do we know who invented this? No, it was way back in the Mesopotamia. Yes, that's where I had got confused. The breakdown remaining and if needed, I got it. Oh, okay, good. Okay, good. Good. So that's the thing. And then we're going to count. We do 11 and then this is 12. 1 and a 2 and then 3. 1 and then 3. And then we have 4. 1 and 4. And then we have 5. 15, 16, 17, 18, and 19. Okay, you know what? Let's do this. You let me know. Here we go. Here we go. Here we go. Let me know what you think this is. Whew. What number? Let me see if I can bring that down some more. There we go. There we go. So let's do some little review. What number do you guys think this is? If I have my thousands, my hundreds, my tens, and my ones, what number do you guys think that is? Is it a whole or a decimal? It's a 4-digit number. It's a whole number. Thank you. 7,921. Thank you, Michael. Yes, does that make sense, Jeremiah? So the 8 looks like this. 9 looks like that. Thank you, Azara. Yes, well done, well done. So it takes me down here. So that's what it is. And then we come down here. What number do you think that is? So we have our thousands, our hundreds, our tens, and our ones. What number do we think? Almost. Thank you. Yes, it is 1,384. Well done, Azaria. Well done, Azaria. Yep. There you go. There you go. Thank you, Michael. Thank you. Yeah, the 5 is a little tricky. So we have our next number. Oh, I didn't do that one. 138. There we go. And then, thank you, Beat Yeet. Thank you, Joanne. Hello, Joanne. So what is our next number? We have our thousands, our hundreds, our tens, and our ones. For those of you that are interested, I do have this abacus available. Oh, I do have it there. And then if you're looking for a 3-digit abacus, a 3-digit maze, I do have that as well. 3 digits is just 3 digits. This is 4 digits. Thank you, Azaria. Thank you, Flower. Thank you, Michael. Yes. Woo. We have 7, 5, 8, 2. Yes. 7,582. Well done. Well done. Thank you, Joanne. There we go. Thank you, Beat. Eat. We have thousands, our tens, our hundreds, our tens, and our ones. What number? Wow. That's pretty good. What number do we think that is? Thank you, Michael. $3,295. Well done. Well done. Thank you, guys. Thank you, everybody. That's what it is. 3,295. Paranormal Dad. I liked my room to be very interactive. I appreciate everybody commenting and trying to read the abacus because this is all about active learning. We're all actively learning. Thank you, Azaria. Yes, well done. 1,784. Well done. Well done. 1,784. And then our next number is, what could our next number be? So we have our thousands, our hundreds, our tens, and our ones. What number do we think this is? Whew! You're on a roll. 5,869. Well done. You guys are fast. I'm so happy you guys enjoy this. 5,869. And then we have our next number. We have our thousands, our hundreds. We have tens, and we have ones. What number do you think that is? Thank you, Sal. 8,000. No, it's not 8. It's 7. 8 looks like that. That's what 8 looks like. And then 4 and 5. You got that. You got that. Yeah, it's just a little typo. 7,745. Well done. Thank you, thank you, thank you. Thank you, Joanne. Okay, 7,745. Now we go down to here. What number do we think that is? How? How? It's magic. What is it called? Magic fingers. Thank you. It is 2,000, so we have 2. 1, 2. That's what 2 looks like, okay? Zersex. So we have 2, 1, 2. We're going to do 9, 5, 6, 7, 8, 9. We have 3, 1, 2, 3. And then Xerxes. Oh, there you go, Xerxes. Thank you. So then we have 9, 5, 6, 7, 8, 9. What we're doing is we're reading the abacus, and anytime the beads are touching this reckoning bar, that's what's being counted. So we have 4 columns counted. We have ones, tens, hundreds, thousands. That's why. And yes, the top is always a value of 5. Thank you. Yes, team money. 2, 9, 3, 9. Well done, well done. So when we look, we have our next number. We have the thousands, hundreds, tens, and ones. So when we look, anytime the beads are touching this reckoning bar, it is counted. So we have our 1 number. So you set the abacus to 0. I do. I like to clear it out. Thank you, Sal. It is 4,700,567, 4. 1, 2, 3, 4, and then 7. Well done, Xerxes. 5, 6, 7. Thank you, Michael. Thank you, Sal. Yes, so B. I always usually zero it out because I want to have a clean abacus before I start my new number. You're teaching me. I'm very happy that you're open to something new and something different.
Now open your mind to me, please. Open your mind.
Thank you, everybody, for joining. Please keep your mind open for something different. It is not new, it's just different. So what number do we think this is? 9918. Well done. Look at that. That is pretty good. You guys are really fast. Thank you, Team Money, Michael, Flower, and Azaria. I've always thought these were cool. But you now know, don't you? Do you understand it? Liv? So when we look, it's 9918. And then we're going to do it again. We have every column that's being touching the reckoning bar is counted. So we have our top bead is 5, and the bottom bead is 1, and then another bottom bead is 1. So when we look, thank you, Team Money. Well done. But it is not 2. Thank you, Azaria. Yes. It is 6, 5, 6, 5, 6, and then 7, 5, 6, 7, and we have 1. A little tricky. The reason why is because the top bead is a value of 5. Yes, the top bead is always the value of 5. So when we look, the number was 2231. 22 looks like that. 2231. But that's not what this is. This is 5, 6, 5, 6, 5, 6, 7, and then 1. All the bottom beads, the value of 1. So when we look, we have 4. This is 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's it. Start from the rightmost rod. No, because this is the decimals. We don't want to start from the rightmost rods. When we are looking, we have our ones. If you notice, there's a dot right here. This is my index. This is my label. My label is my ones place. The rightmost will give me the tenths, so we can actually count money. We said ones, my decimal, tenths, and my hundreds. More simple than I thought. Yeah! Right? And so our next number is, thank you. What number is this? We have our thousands. We have our hundreds, we have our tens, and we have our ones. What number? Thank you, Jeremiah. 2,700. Thank you, Michael. 39. 5, 6, 7, 8, 9. 2,739. Well done. Well done. Thank you, Sal, for the follow. Okay. And so that's what it is. We're learning to read the abacus. After we learn how to read it, make it simple, easy, fun. Thank you. I appreciate that. Thank you so much. Thank you. I'm happy you had fun, right? It's one of those things like math should be fun. And it's one, and so this is what it was. It is a maze. I actually have 2 different kinds of mazes right now in my TikTok shop for those of you that are interested. For more mazes, I do have a full collection over here. My name is Lynette. Thank you so much for the gift. Thank you so much for the rose. So for those of you that are interested, I do have a full library here. I'm on my 15th book. I have 14 books published. My name is Lynette. I've been teaching abacus for about 20 years. Thank you so much for joining and keeping your mind open.
Oh, I love it. Great stuff.
So here is my book. This is, I never knew how to use my grandma. We never asked about it. You should ask about it. Fairy Fitness. That'd be awesome. So here is another book. This book is a 3-digit puzzle. We talk about the hundreds, the tens, and the ones. I do have a big one. Or that one over there. It's the teacher's one, but I don't have a class anymore, so my class is online. So that's why I use the smaller abacus. So here is the maze, and what it is I give you the maze, I give you the abacus number, and you're supposed to know, you're supposed to read it. You also have the opportunity to download a mask maze so you don't see the answers. The answers are on the path, and you try to follow the path to the end. And then there's also another one which is called a reverse maze. The reverse maze is, I give you the number, I give you the path, and you need to color in the abacus to make it correct. And if you're interested, I do have the answers in the back, just in case. I will definitely getting some stuff from your store. Oh, thank you so much. I appreciate that. So I do have a TikTok shop, and I do have my full collection of books is available over here. So then this one is a 2-digit maze, 2-digit puzzles. It's the same thing, but this time we're only talking about the tens and the ones. And again, before every book, I always provide information on how to read the abacus. So this is a little review on how to read the abacus with the single digit, and then I show you what a double digit looks like. So just in case we forgot that 28 has the tens and the ones, we have the tens and the ones. That's the store name again. Oh yeah, my store name, that's my name. Hello, thank you so much. It's a 4 and 1. Oh, yay, beat. So if it's a 1 and 4, then it's the Soroban. The Soroban is the more modern abacus. Yeah, no, thank you, Azaria. Thank you. I appreciate that. Can an abacus help me during engineering mathematics exams? As long as it's adding, subtracting, multiplication, division, it can. But I can't tell you because that's above my pay grade. I only know how to add, subtract, multiply, and divide. And I only know how to do it with the abacus. I apologize, but that's all I know. Yeah. So for those of you that are interested, and then I'll be having more. And then after you do that, Azaria, you would want to go into understanding how to add and subtract. I'd go into like how to make a 5. Oh, but you know what? I actually have after this one, if you wanted, there is an introduction to abacus for adults. This has just been published. I just published it, and it talks about all about adding and subtracting. Yeah. So, can I do? I'm sorry. Can I do one with the math answers? Apparently, the ancients have base 60. You know, that's really interesting. Base 60. Thank you for showing me how to use this. Makes a lot of sense. Thank you. I'm so glad I came across that. Not a problem. Not a problem. Thank you guys. I'm not sure. Love, hate, just now. I'm the best. Can I do the math answers? I don't know what that means. I'm gonna answer. I'm gonna answer one of the math and see if I can. Oh. You know, for the maze, is that what you're talking about? Okay, here. Let's do a maze. Ta-da! Okay, what number do you think that is? And this is the 3-digit one. This is a 3-digit maze. So we have our numbers. We have our hundreds, tens, and ones. What number do we think that is? 2, 1, 7. Yes, almost. 2, 1, 2, 1, 7. 5, 6, 7. Not 3. 3 looks like that. 2, 1, 3 looks like that. 4 looks like that. 2, 4, 7 looks like that. But we're looking at the 1. So it's 2, 1, 7. 5, 6, 7. Ah, ha, ha, ha. All right. Because it's late. I'm surprised you guys are up learning math in the middle of the night. It is so late for everybody. Crazy. You guys are crazy. I love the sound of clearing the abacus. Oh, yeah. The symbol itself represents. Oh, great. We have the number. There we go. What number? It's like. Yes, thank you, James. 92972. Well done, well done. It is late? Are you live every day? I am live every day. It is late. I am live every day. I try to be here a little bit earlier. I also go in the mornings or sometimes during the day. I try to be here. I'm on Pacific time. So I try to get here about 8 o'clock. Sometimes it goes to 9, depending on what sort of what I'm trying to do. But I'm trying to get here at 8 o'clock. I'm trying to push it more to 7 o'clock Pacific Standard Time, but that's been a little bit difficult for me. But I will try to be here a little bit earlier. I do realize it is late for everybody. So what number? When we notice we're only working with 2 digits, right? Even though there's 3 digits, don't forget the 3-digit, this can be a 0. Thank you, Michael. Thank you, Jeremiah. Thank you, Fairy. Remember me. Okay, sassy baby. Right? So we have 52. And then what do? We have that. What's our next number? We have our tens, our hundreds, our tens, and our ones. What number do we have? Thank you, Fairy. Yes, fitness. 6, 2, 7. Well done. Thank you, Jeremiah. Thank you, Michael. Yep. And then we have that. How do you explain this? How do I explain what? How do I explain the numbers? So we have our numbers. Every column is a place value. So we have our ones, 5, 6, 7, 8, 9. We have 4, 1, 2, 3, 4. And then we have 7, 5, 6, 7. Anytime the beads are touching this reckoning bar, it's being counted. So these three columns are touching the reckoning bar. Anytime the beads are not touching the reckoning bar, like these two, they're not counted. This is not counted. So you don't add that to this number. This number is 4. 1, 2, 3, 4. When you see this, notice the top bead is touching the reckoning bar. Now we count it. So we have 5, 6, 7, 8, 9. And we do it again here. 5, because the 5 is touching the reckoning bar. 6 and 7, because the two beads at the bottom is touching the reckoning bar. So then we have, thank you, Joanne, 749. Thank you, Joel. Is it Joel or Joel? That was a comedian. A comedian was talking about how Ireland talks Joel. Billy Joel. So we have our hundreds, our tens, and our ones. Did that make sense, Sassy? Both. Do you know that comedian? I forget the comedian name. Billy Joel. I forget the comedian who said it. Oh, it's so funny. Thank you. 708. Well done, well done. So we have our next number. We have our hundreds, our tens, and our ones. Thank you, Sassy. 719. Well done, Joel. Thank you, Fairy. Yes. Yes. Well done, well done. Thank you, Michael. Thank you, Sassy. So we have our hundreds, our tens, and our ones. Oh, what number is this one? This one's a 3. That's what this is. Yep. Cool. Yes. I used to play with these as a kid. Oh, yeah. Yeah. It's more in America. It's been gifted as it's been deemed as a children's toy, but it's actually not a children's toy. It's actually a counting tool. It's a math manipulative. Well done, Fairy Fitness. Thank you, Sassy. Yes. So our last number. This one, that one. Well done, Jeremiah. Thank you, Michael. Thank you, Fitness. Thank you, Sassy. That's it. That is it. So these are my books. These are my books. And I also sell the Abacus too. The Abacus is a 7-column abacus. It's made out of plastic. And it's easy to move. And yeah, easy to move and simple to use. Simple to use, easy to understand. So we have books. I have books. I have my books. It's used for counting. Oh, thank you so much, Jeremiah. You're a great teacher. I used to love counting. Yes, I can count very well from 0 to 9. When we look, we can do 9, 9, 9, 9, 9, 9, 9. And that's what it is, which is funny. The funny thing is it's all about the 9. You can't go higher than 9. But you can do different placements. You could do 1 and a 0. So that's 1 and that's 0. So now we have 10. Now we have double digits. But if you think about it, you only go from 0 to 9. Yeah. And then we do 11, 12, 13, and then 18. Thank you, Ghost, for the follow. All right. How are we doing? Thank you so much. Whew. Okay. Yeah. All right. But I think it is time. I've been on for a little bit. I'm getting kind of tired. But I do like the midnight math. So those are all my abacus, and those are all my mazes. And then I have books. I have a lot of books. And these books are all abacus specific. which is very interesting. So for those of you that are interested, what we could do on the abacus, we could do addition, subtraction, multiplication, and division. Oh, thank you, Jeremiah. I thank you. I appreciate that. So abacus is like having Sudoku, like crossword puzzles, jigsaw puzzles, and word searches. For those of you that are interested, I do have online classes, abacus tutoring. I have workbooks and worksheets. So, but I'm also here live, and if you have any questions about abacus, let me know. Let me know if you have any questions about abacus. I do enjoy talking about abacus, and I do believe it's the greatest thing next to sliced bread. Yeah. So we talked about place values, we talked about moving the beads, and we did everything, actually. We did it kind of like all over the place. But it is what it is. And then I'm going to work on some more books so we can get it out the door. I'm going to be working on some multiplication maze books. Thank you, Jeremiah. Sleep well. Thank you so much, Jeremiah. I appreciate that. Okay, so thank you everybody for joining. I am going to head out. I do apologize, but it is late, and I am going to try to work on some more books. I have 14 books available, and I got to continue on. I got to continue on to flood the market. Could you throw an extra 2 stones and do the base if you call the top 7 equals 6? You know, you could. So like for this one, I mean, the only thing I can think of is like you can do your 6 times table. So 6 times 1 is 6. 6 times 2 is 12. So we have 10 and 2. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. But this top wouldn't equal to 6. I don't know why you would want to have this top to equal to 6. I think having 5 is more versatile. Yeah. Because these two are just 5. This is 5 and 5. These are increments of 5. And so when we look, we have 6. So this is 5. And that's 5. Yeah. All right. I am not being coherent, but I'm not sure. Okay. Wait, what's the next one? It's a 5. That's what a 5 is. This is 10. So when we look, we have 1, 2, 3, 4, 5. You trade it in, and this is 5. 6, 7, 8, 9, 10. Trade this in to make a 5. So now we have 10. 10. Okay, see you later, Fairy Fitness. Thank you so much for joining. And then that's 10. 1 and a 0. So we do it again. 11, 12, 13, 14, 15. And then 15. And then we do it again. 16, 17, 18, 19, 20. This is 5. We bring that down. There's a lot more trading in. There's a lot of trading in. That's why Japanese came around and made it more efficient. That's what this is. So the Japanese came around and made it more efficient. Yeah. Oh, Sassy, I'm about to go to sleep. Have a good night. Thank you so much for joining. Yeah, Dark Star. Thank you. That was a good question. But I don't know about the making it a top equal to 6, though. I don't know about that. Have a good night. I'll see you in my next live. Yeah, this was a good session. Thank you guys for joining. I do appreciate it. I only mentioned it's possible because it says that there was an ancient base 60 version. Base 60. Hello, Edric. Thank you so much for joining. Base 60. I don't know. That is above what I'm trying to figure out. Base 60. Because that means to go from 1 to 60. We already do a base 10. And they talk about base 5. Base 60 doesn't make sense to me. Oh, thank you, Sassy. Not a problem. Not a problem. I enjoy teaching everybody. I enjoy teaching the Matrix how to use the abacus.
Welcome to the real world.
Thank you. Thank you, thank you, thank you.
Now I know.
And knowing is half the battle.
Base 60. Yeah, I don't know what base 60 means. Ancient base 60. That's a new one. I'm not sure. I've heard of base, excuse me, what is it? Hexadecimal. Hexadecimal. You would have to have like letters, right? I got really good at it now because of you. Oh, good, Sassy. Base 16. Yes, I've heard of base 16. Thank you, Aces. Yeah, I've heard of base 16, but I've never heard of base 60. 60. That's hex. Oh, yeah, that's right. Yeah, because we do CSS. CSS colors are hexadecimals. See you later, Sassy. I'll see you in my next live. Yeah, I'm trying to just thinking a little bit. Okay, have a good night, Sassy. Thank you for joining. But yeah. Oh yes, 16 and 2. But if you read the abacus thing, it says 60. Yeah, I don't know. That's a new one for me. I've never heard of that one. Thank you, Darkstar. But yeah, I've never heard of that one. 60. Babylonia used base 60. Babylon. What does base 60 mean? Okay, Sassy. Thank you so much. You too. I don't know what base 60 means. Does it go only from 0 to 60? And then what happens after 60? After 60, like 61. I can't. I'm feeling very tired. I will have to look up base 60. That is what I will do. Babylonia. Base 60. All right. I will look that up. There's a lot of things I got to look up now. And Harry Houdini. Oh, I don't know if yeah. Time is base 60. Oh, okay. That makes sense. Time is base 60. Well, minutes and seconds are base 60. But then our hours are based. Huh. That's very interesting. Yeah, that's okay. That makes sense. Thank you, Aces. Yeah. And then ours is base 24. I guess, the other reason why for base 60 is because they didn't have anything higher than 60. If you really think about it, right? If you really think about it, I mean, how many times do you have to go higher than 60 back in the day? Right? Only now do we have like mass production do we need to have something higher. That's interesting. Never learned this. Hello, year. Yeah, here. We're going to count on the abacus. So we can count 1, 2, 3, 4. 4. And then 5. The top beat is always 5. We have 6, 7, 8, 9, and then 10. 10, 11, 12, 13, 14, 15. The top bead is always 5. Anytime the beads are touching the reckoning bar, it's being counted. This is 5, 6, 7, 17, 18, 19, and then we have 20. That's it. That's how you read the abacus. But yeah. All right. I'm going to head out. Thank you so much for joining. I'm going to shut down. I'm starting to feel it. All right. Thank you guys, and I will see you guys all in my next live. Bye everybody. Have a good night. Have a good morning. You guys have a good morning, everybody. Good night, Edric. Thank you so much for joining. Thank you so much for checking in. Bye.